It's a Moritz Klein design. I love Moritz Klein's videos. Moritz Klein, associated with Erica Synths, I'm not sure how, but Moritz Klein puts out these videos where he sort of glosses through the design process of electronic music equipment, modular synthesizers, drum machines, things like that, all kinds of stuff. So we did this video on a 7400 series Logic sequencer for drums. It's not that I want for sequencers. I've got marbles that can do drums a little bit. It does kind of like marching drums. And I don't know, I need to build like a couple ADSRs and stuff like that. And then I'd be able to make like 4 drumish sounding sounds. I don't have a lot of stuff in the synthesizer I'm learning. I bought a lot of the requirements, but I have enough that I can go boo, 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 ba, ba, ba with a keyboard. But aside from that, the whole thing about modular is this thing should be managing itself, right? I just kind of push the connections and it'll make the music. I can't quite do that with mine, I don't think. Maybe Julian, when he gets here on Saturday, if he gets here on Saturday, can give me a little bit of a rundown of that, and maybe we can put something together. It'd be nice to kind of get to know the reins. The only problem is, although Julian is a teacher, I've found that when you have somebody show you stuff on their modular synthesizer, they don't explain stuff like I do. They don't, oh, I need to connect this to here in order to make it do that. Those, blah, 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 and you need one of these here, you need one of these here. And I'm like, wait, why? So anyway, Moritz Klein makes this drum sequencer, and it looked really fun, and mostly it was 7400 series Logic. And the cool part about 7400 series Logic, everything works in 5 volts. Everything is fairly basic. There's no software. We can jump in and look at what this thing is doing with an LED. The only problem is Moritz used, what is it? Not TTL level, it's CMOS level, which is 12 volt compatible. I'm using 7400 series TTL logic, which is 5 volts. And I don't necessarily have the same parts. So we're gonna try to build this drum sequencer under the same like technology, only with the slightly newer, lower voltage stuff, and get it to work. And so we've had to cross-reference data sheets. We're using a counter chip that Moritz is not using, which concerns me because I'm wondering if later on in the project you would want to use that second counter channel. We have a singular counter, whereas they used a dual counter. I don't think that's going to be a problem because we're kind of working off of the final schematic and not rolling through the video. I don't want to necessarily, like, you know, diminish Moritz's video. You guys should all go watch that, all 3 of my viewers. But yeah, that's the new one. Okay, sorry, I'm just doing a little setup here. Okay, so if I view that, that's the new YouTube. Okay, cool, chat's all set up. I'm so sorry, Twitch. I'm in violation of your toss directly. Come at me, bro. Come on. By putting both YouTube and Twitch chat on the same screen. I am a filthy, dirty violator. Far be it from me to simply want context for the things that I'm reacting to. That would diminish the experience of the Twitch viewers. Stupid. This here, that there. Ta-da, it makes sound. Yeah. It would be nice to see him do that for my machine. Unfortunately, though, my machine is not well labeled. That's the one thing about the 3D printed front panels, is that my labeler produces perfectly flat labels and the 3D print has kind of a surface to it. And I guess I could use ironing maybe to like really flatten it down. You know, it would be nice if I was capable of creating the things that I've been trying to create faster. If I had simply bought a kit to convert the printer into a linear ultraviolet ink printer, ink tank printer, then I could have panels go on the linear thing and print full color labels, which I don't know, what would I make those in? I don't remember. It was like Microsoft Publisher was what I used to use, but what's the Google equivalent of that? Is it Google Publisher? That's probably a way to do like a blog. What is that? It's just like an emote. What is it? Do we allow emotes in here? I don't remember allowing emotes. I don't recall letting those through. See notes. That printer project I would really love to have worked out, because then I could make the panels that I really want, which is carbon fiber, and then have color printed labels on it, because there are a lot of modular synthesizer modules. Could you believe it? Could you believe that there's a lot of modular synthesizer modules, and it's tough to keep the ins and outs straight. And then I've tried Sharpie, small Sharpie writing on the 3D print, but it's PETG, and freaking nothing sticks to PETG. Nothing sticks to it. It's like Teflon. It's the microplastics in our balls. I can't get labels to stick to it. So I don't know what to do. And incorporating the labels into the print, it gets real sloppy, because again, it's PETG. I'm using a strong plastic because this thing has to take the force of me going when I get mad at nothing working, because nothing freaking works around here. Yeah, so anyway, that's why it's prohibitive for Julian to show me how my modular synthesizer works, because he doesn't know what any of this crap is. And I need to find a design for an ADSR. I think that's like two rack units, because the one that I have takes up a bunch of space. It's a really good one. I like it a lot. Takes up a bunch of space. I'm wondering if I can find either an analog circuit that'll do the same thing, or use the same circuit and build it on my own stuff and flip it 90 degrees. It all works, just not how you intend. It works, but it's like, it's just a struggle bus to get every certain thing working. Most of the synthesizer works. I think there's one module that's a little bit squirrely, and I need to put like into the test setup so that I can really like drill down on it and do some intense troubleshooting to find what is most likely a singular tiny little solder joint that looks fine but isn't making a connection. Because when we tried to reflash the software on this mutable instruments module, it would not take the software in, and I did not have the means to do the individual circuit testing that I should have done. It would have made a lot more sense when building something as complex as like marbles and clouds and all that stuff if I looked at the different systems of functionality apart from the microcontroller first. Because you got this big STM32 microcontroller, $15 microcontroller now, sitting in the middle of all this stuff, and it's supposed to coordinate all these things, but you don't know if those things work. So building the individual setup and then testing the voltages to make sure they're good first, then you put the $15 microcontroller down because it's at risk of being blowed up by a bad circuit, and then program it and roll from there. Because then you know, it's like, yeah, my hardware works. There are test routines that Emily built into those systems, but the GitHub is a dump of code. The GitHub is literally like, I'm out, here's everything, bye. Don't call me. Like, just slam the door. So what we have are the ruminations and the remnants of test routines that were likely to have been run by Emily when building these things. That, like, God, that would be awesome. And I also completely understand walking away from the whole thing is to be the name for a simple, I am actually legitimately overjoyed that all of the code and the information is out there, because the Emily designs are like cream of the crop. They're like the best. They boil everything down, which I like. They don't have a lot of superfluous weird stuff hanging off on all the circuits. That kind of stuff, I understand why it's there and where it comes from, but it's never explained, right? And so the Emily Gillette circuits don't have that. They don't have that. You can look at it and you can go, there's the op-amp circuit, and this is why it exists in the way that it is. And you can look at the history of design and you can see, oh, that was replaced with an ESD capacitor, and then the specific static electricity protection capacitor was, I guess, obsoleted, and so now it's a capacitor again. You know what's going on because you can look through the history. This very much relates to how I did the IED stuff. But you boil it down to its component parts, and just the dream, being the person that builds these synthesizer modules that people like. All those individual pieces, all that wrapped together is like the golden egg. I would love to be the guy that makes the thing that people like. I don't know what that is. And I've, 30 years doing 35. No, when I was like 7 or 8, 9. It was really in my teens that I got very into electronics. But all those years that I've been puddling around with this bullshit and I haven't found the thing. So I'm the guy that makes the thing that people don't need. That actually, yeah, no, that sounds about right. So anyway, yeah, the Emily Gillette designs are amazing, but the one that I have, I think, is still wrong, and we don't have her routines to test the inputs and stuff like that to make sure that I haven't badly soldered something. So I really need to sit down with the oscilloscope and I need to look at the voltages that are coming out of individual plate. Like, oh, this op amp's good. I'm giving it 10 volts. That should equal 3.3 volts here. Yes or no. And then that'll uncover what's not working about it, what might be wrong. There might be a bad gain somewhere in there, you know, a bad resistor in there. And all this stuff is 0402, so it's the size, smaller than the smallest of the small, which makes it very frustrating to troubleshoot through. But yeah, anyway, no health emergencies. I didn't have to go to the hospital on my birthday, in spite of forgetting my phone, which can become that kind of emergency if I'm not careful. And I wasn't careful. I had like 2.5, I had 3 beers. That's 3. They were Pilsners, so yeah, it's day after my birthday. We did like a surf and turf kind of steakhouse dinner, and I got to taste Wagyu for the first time, and I will tell you, it's not worth it. It is delicious, but was it worth the expense? Yes, but no. I'm glad that I've tasted it, and that's it. You know, I don't need it anymore. I'm gonna say, you know, I'm never gonna sit down and go, I could really use some Wagyu right now, because it's like, it's almost different than meat. And this was prepared like really well. Like, this place knows their stuff. They did I don't know what the spice, I don't know what it wasn't like dry rub, but it was it had kind of like a sweetness, like a sweet thing on the outside, and it was just like melting. What's up, Madam? How you doing? Yeah, so anyway, that was it, and I didn't have to go to the hospital. I didn't have cake. I don't have cake. We had cake. I didn't have cake. Nobody had, well, they had cake. I did not. I don't do cake. And my glucose levels were perfect for the whole night, which is enough for me. That makes me happy. So yeah, that was birthday. I kept it low key because it's not an important birthday. Where are my LEDs? Oh, here we go. Where are my LEDs at? I'll just display the clock. That goes to positive. This is a good mix. This is a good mix. I like it. Which one is it? This one. There you go. I'm still getting used to the Stream Deck after all this time. Friend of mine asked me what he should do in buying a Steam Deck, and I didn't really know what to tell him. I don't know where do you buy a Steam Deck from these days? I guess directly from Valve, or try to find like a subreddit where people are selling them. I guess, I don't know. My Legion Go has, of course, been collecting dust. One of the things that I would really like to be able to do with that Legion Go is get it running as an RC controller. It would be amazing as an RC controller because you have the trigger for throttle and, you know, the simple sticks, but then you've got a big HD screen in the middle. And it would be wonderful to use it sort of in the same way that drones are being utilized these days. I saw a really cool picture, and I shared it on the Discord weeks ago, of this filming robot that they have in order to film a concert. So you can minimalistically, you know, have just like a little robot arm, and it could be doing like cool sweeps and stuff and filming like a stage concert, right? And the guy controlling it had all this gear on, and part of all that gear was a Steam Deck. And the Steam Deck likely running a Python program. That's what all my searches said. Some kind of Python program maybe, or some robot controlling dealio. But anyway, like that puts a lot of really good controls at your fingertips, and it's already ergonomic, and it's just perfect, man. having a big HD screen right in the front. And I'm wondering what they used in order to get that radio connection, as well as all the controls controlling all the doodads. People get too absorbed and appreciate just surviving another year or another day. Back in my day, it was a bit more Darwin driven. I don't know about that. I don't know about, hey, are you 10,000 years old? Were you out there like spearing buffalo? Like, I know life is tough, but you know, celebrating, I don't know. I don't need a big flashy party, but I am glad that other people had cake. For personal reasons, I do not have cake because 30 some odd years of diabetes, you kind of learn that like you're measuring food intake against how you're going to feel later on. And I'm not going to say no to a sandwich because I'm fat. All right. Everybody, no, you're not fat. No, I'm fat. I just know how to dress it so that it doesn't. I buy shirts that are large enough that my buttons aren't like strained under the pressure. It may be slightly hidden, but it's not a thing that I'm unwilling to engage with. I am overweight by a lot right now. The trend has been going down. I've been losing weight, so I'm going to keep that going. But yeah, it's like I'm going to say no to the cake in spite of my desire to have it, because I know that it's going to make me feel bad in the afternoon. Like, right, I'm just going to feel bad because my glucose level is going to shoot straight up. I'm going to give a ton of insulin. Nothing will happen for a while, and then nothing will happen for even longer than that, and somehow it'll just plateau. And then I'll give another giant bolus of insulin later on in the afternoon, and then it'll maybe move a little bit, and it'll just very barely start to go down very, very slowly. And then it'll go low. And it's like, I just don't want to do it. So I passed on cake, and apparently everything was just completely honky-dory for the rest of the day. It was great. But I'm happy to have like a birthday celebration. It's great. You can see in the tags that I added birthday girl. So far, this is not impressive, but we'll build it up a little bit. We have some other thingy-wingies to throw at this thing, I believe. Oh, there he goes. That's the podcast that we have on right now, so go sign up for that. I hope we can actually make some good... Well, to make the noises that the sequencer is going to produce, I guess what we're going to have to do is bump the 5 volts up to 12 volts, which if they are just sequence triggers, which I think were a little bit more complicated than that, I think, we'll have to figure out how to get it into the modular synth. Then we could give it noises, but I only have one ADSR. And you need some kind of an envelope around the drum noises. They need to come in and out. What's the clock source? Fuck would you ask me that? It's a great shame to my family that I put a 555 in there. That's a 555 timer. It is a 555. I've covered my shame with a wire. Oh. I had to look up a different configuration from the one we used yesterday. It moved the potentiometer to the 2 different pins. And so that gave us a 50% duty cycle on the ups and downs coming out of the thing. And so those ups and downs can get fed into our counter, and those produce a clean signal in a weird spot. And I'll explain it. I'll explain it when we get into it. It could have been at AT-Tiny 13. I have a couple of those. I have a couple through-hole AT-Tiny 13s. We could still get out of this mess. I could get rid of all this crap. I could incorporate one of my cool-looking little LED screens. Here, check these out. I can incorporate a BPM readout so we can get beepums from our clock source. Cool flashy LEDs. That's the best part about 7400 series logic, and they really didn't let us explore that in school. Are they in here? I guess we're not in here. There's somewhere around here. I got these like cool LEDs. I don't know where I stashed them. We looked at the LED collection at one point, but it actually these are some of the coolest. These are from a thing I bought for my VW back in the day. They were for like a boost indicator, and they matched the VW LED color, which is this sort of deep blue, which is a little bit purpley, but not. It's not like this like sort of sky blue. It was like a deep purpley blue that I really love. Can't find them anywhere. And I've certainly bought enough LEDs to call off the search for a little bit, because it's not like I'm doing anything with all of these. I don't know where my specialty LEDs are. They've got their own little like bin, I think, that they hide in. But I had a bunch of like weirdo displays and stuff. Oh, you know what? They were on their own little static pad. Is that like up here? They're on their own little like static foam pad. No, I don't see them. I don't see them. I don't know where they are. I'm too disorganized. I need to do a cleanup pass on this whole place. Man, there was more discussion. It always circles back. I really want to make that 944 project one day. It's stuck in my head. I can't stop thinking about it because I've got the 3D scanner, and I just love the 944 chassis because I think I could fit everything inside of the axles. And so the only things outside of the axles would be like the taillights and the radiator. So maybe the headlights too. It'd be so cool because it's this just wide, low to the ground, not big car. It's actually quite a small car. Yeah, it'd be really cool. Like the super fast Matt videos from like 2020-ish, where he just like is like, yeah, I just scan it. Here's where the bolt holes are. Like, like fuck, I could do that. I could do that. I don't have space for a car though. That's the problem. I would be putting so much into it. We could be super extra doing a complete resto mod, giving it modern systems. Man, you guys know how extra I can be with these car things. You know that I boil cars down to nothing. We hacked the LIN bus in order to speak to the steering wheel buttons on a Mercedes steering wheel, and we hooked it up to BMW pedals with a digital gas pedal. I am crazy. Yeah. And then I would drive it to the supermarket. What the fuck do you think I'm going to do with a car project? Find a place to go to Cars and Coffee. Oh, to see the faces on the Porsche elitists. Oh, they are a crunchy sort. They are so much fun when you do something stupid to a Porsche. Oh, they're fun. Oh, they're fun. Yeah, we have Cars and Coffee around here, and not for lack of people who have huge budgets. There's some very interesting cars at those events. They're gonna have a heart attack, yeah. So I, way back in the day, 2010 9876. Jesus. When I had the Porsche project, I was active on the forums for the LS1 swaps, and the funniest progression of posts. It started with, "Oh my God, I love drag racing this car. I can't stop drag racing. My axles are broken." It was all the same user, all those in a row. It was beautiful. Shaking their heads and tutting. Did you see that electric abomination? Well, the car's already an abomination. It's really kind of the abomination of Porsche, because it's kind of an Audi design mostly. The motor is an Audi design too. That's how you know you're driving it properly. Yeah. The axles from the transaxle were the soft point, and if you upgraded those, you might spin the torque tube, which is very bad. I was reading into how to tap into the CAN IHS bus in my minivan to have a microcontroller do stuff to it, but it sounds like I'd have to reverse engineer and debug all the traffic myself. Unfortunately, unless your minivan is super popular, that's sort of where my love for the older BMWs comes from. Because with the older BMWs, everything is documented. Everything. They know everything. They even know like memory registers of the ECU. It's crazy. And you can find that all online, and you can find all of the German engineering programs that will yell at you in German if you get something wrong that can break your car. But you can get into the subsystems, you can get into lower level stuff, and it's really cool. I haven't done much with that except for just maintenance, because the car that I have right now is a car. It's not a project car, it is a car. It has to get me from A to B. That's it. Because you need a car to survive in America, especially where I'm from. Maybe not New York City, but in America, you need a car. That's not to say, no, New York City is America. I'm not a weirdo. I'm not one of these idiots. Anyway, so to survive outside of the largest city, I could maybe get by in Philadelphia without a car, maybe. But there would be certain scenarios where I'd have to like get an Uber across town. Like, just because Philadelphia, third largest city, right? In something, I don't know what. Even then, you still need a car. It's just the way all the infrastructure is. So that's where the station wagon comes in. Now, the station wagon is chronic rust at its rear jack pads. I need to get on that at some point. But again, you guys see me every 3 times a week. I sit here and I go, I have so many things that I need to do, and none of them are changing. None of them are getting off of that list. I hate it. I hate it. It's the exact same thing that killed my my sedan, the BMW sedan that I had previously. I really liked it because that was a fast car, but that one also got chronic rust at the jack pads. And I know some of y'all are chronic rust experts, but I'm not great at welding, and I don't have my welder anymore. Yeah, it's amazing how well documented the Bosch BMW ECUs are these days. I can change the map on mine running just by using my phone in under a minute. It's crazy how accessible that is. I reflashed all of the software on my anti-lock brake module with the specific sedan configuration from Germany with a couple clicks of my laptop. It's like that level of availability is what keeps cars around. I don't know why that's not like a standard of what car companies put out, but it's what scares me about buying any other, like buying something other than a BMW now. I have seen the promised land. I know what's like, I've seen parts where I could scan an E92 and get into it at that level. Crazy. But yeah, that level of sort of chicanery, pokery, is what attracts me to that brand. I'm a chronic rust person, jack somewhere else. That's actually load-bearing rust, and I would appreciate it if you wouldn't try to jack that up. This is a good mix. I like this mix. What were we listening to again? This is Deckard, and it's just called episode 118. It's the Armory podcast. There you go. They probably some music collective that took over an armory and throws big crazy parties there. I need to go to a big crazy party. I haven't been to one in centuries. I'm sure it would kill me in my 40s, but it would still be fun to listen to a bunch of boom boom computer music in the dark with a bunch of people. I was reading about how to tap into the can. Oh, I already got that one with the minivan. I was imagining having it towed to the dealership after I break it and telling them, yeah, I sent this packet on the bus. Oh, yeah. That, a minivan, I don't know what year, I don't know what equipment they're using these days. That would be pretty scary. And actually, they would instantly recognize that they have you over the barrel, and they would want to put in new like ECUs and stuff. So you'd be leaving for tens of thousands of dollars probably. But I mean, like the Arduino community with the CAN bus capabilities of some of the more modern Arduinos and other microcontroller hardware that is compatible have gotten into CAN hacking. The one thing that I wish they would do is plug their stupid crap into a Mercedes so that I could see what the backlighting packet looks like. I don't know what that looks like. It could be a completely proprietary packet. Maybe I know an address range, but I don't know what data to put behind it, because somewhere in that Mercedes, somewhere in that bus is a packet that tells the rest of the Mercedes doodads, hey, we're at backlight level 10. And so everybody turns on their orange LEDs at just the right brightness. I don't know what that packet even starts to look like. I would need somebody who's sniffed the feet of the Lynn bus. Just gotten in there with those, yeah, just sniffed the toes of the bus so that I could know what's going on. But unfortunately, I can't find that. Maybe it exists now. I haven't looked in a long time. Let's take a look. Let's take a look. We can just Google toe sniffing. No, wait, I don't want that to go in any of my search things. Can you imagine what the algorithm would do with me? I'd be immediately ragdolled and thrown off a cliff. So we're looking up Mercedes Lynn bus backlight packet. What? We specialize in ambient lights. Yeah, I mean, you tried. That's not really what I'm... nah. Automotive OEM replacement. No. Amber lamps. RGB ambilight. Why doesn't our 2004 GLC 300 have ambient lights on? 24-volt Mercedes. Lynn bus explained and how to measure it on a Mercedes-Benz. You, YouTube video, look like you have the information, but you're probably not going to share it in this video. I'm going to leave this up for later. Thanks for the info. Lynn bus explained how to measure it. How do you measure a bus? With any luck. No, it's not. It's going to be surface level. It's going to be surface level. Give me a packet. Show me a backlight packet, please. Please, I know you have access to that information. I can maybe look up the Lynn standard, but from what I remember of it, it doesn't say like, it'll say like, here's the address for lighting stuff, and then you'll have data, and you don't know how much data is behind it. So, actually, if Lynn signal from the alternator, the lighting, I don't think the lighting packet would be in with the alternator. This is the top tier content I'm here for. I don't know how prolific the foot fetishists are, but if they're enough to get me a few viewers. Okay, well, it's fascinating. I think somewhere on the screen, there might be a picture of the packet, but at this resolution, I'm not getting my ones and zeros out of this. And I don't think it would be sitting on the same bus as the alternator. I think the lower priority backlighting signals for like the dashboard and stuff would probably be on a different bus. Or maybe they're not. I don't know. Maybe not. This doesn't have links to any other information too. Whatever happened to information on the internet, huh? What has happened to us all? Yeah, I need like some raw data in order to like pick it back out. But yeah, what threw me on that tangent is that there is a more filled out community of people doing that kind of digital stuff with cars in general. So it's possible maybe you wouldn't find something hyper specific for the minivan, but you could find people doing very similar things. Yeah, you'd have to scan it yourself, but there are programs, and I don't know them anymore, and there are probably freely available programs, I'm guessing, that will organize all your packets and stuff, because these buses work off of a priority system. So you've got a certain higher priority messages coming through often, and you kind of have to sit there and sniff a whole variety of messages in order to get the signals that you might want to communicate with or interpret or manipulate. I've done it before. We did it to try to find forensic data in a car. And they would not get us a car because it was just the beginnings of saying, can we do that at all? And, you know, for me, I'm like, yes, the answer is yes, we can do this. This is totally available and easy to do. I need a car. I need to go to the junkyard, or I need to, because we bought individual pieces of a Chevy in order to do this and show that we could take over the the odometer and stuff like that. But it's like, this is just like very surface level what we're doing here. We are literally just making the needles move on this thing, which I wish I got to keep that, because that would have gone into the simulator setup in a second. It was a fully digital, CAN bus activated dashboard. And then we had, do we have a radio? I think we might have had a radio, and then we had a, the CAN bus thing, and that was it. That was our car. And I was like, please listen to me. We need like a whole car with a wiring harness and everything, because cars are vastly complicated machines. And I was like, sure that there's probably forensic data sitting on something. But they were just proofing out so that they could write the proposal for everything. So, but yeah, that was my involvement with that sort of digital car craziness. You may have noticed that this thing is counting. What is it counting to? Oh, it just stopped. It just went back to 0. We'll start up in just a minute. This is like the good part of the mix too. I usually chew the fat with you guys for like an hour, and then we start off. But like these mixes are like an hour and 20 minutes. And in that last 20 minutes, they're playing all the good stuff. But because, again, I don't pay for this music, so it only shows up in the live Twitch broadcast. Madamu is not listening to this music right now because it's not broadcast to YouTube, because YouTube would hang me if I play even an iota of a copywritten song. The song that's been getting to me lately, and I'll just pause the music for this just so maybe somebody knows it, probably not, but it's been driving me absolutely nuts. I used the Google Music thing on the Android phone to try to tell me what the song is. I think it was used in a Martin Pants video, and I don't know if it was an early era, middle era, or late era Martin Pants, because he starts off not using any music, and or it's all copywritten music, and maybe he had Google smear over all the music. That's what I did with some of the early VODs that I uploaded. As YouTube, Google was like, "This is full of copyright music. We've got to actually kill you." And I said, "Whoa! Maybe you could use that AI thing to try to mute the music and keep my voice." And that became a job in and of itself, and so I stopped doing that. But it's possible that the early era videos used this copyright music. I listened to it, and then it was smeared over by the AI and deleted. And so I'm going back to these videos and I'm watching them again, and I'm going, I cannot find this song, and I know he used it. I am being gaslit by the videos. The videos might not have this song in it, but it's like, it's got kind of like a 60s feel to it, with sort of like a jungle flair, like a dot 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 dot, and then the melody that I remember is da 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 da. That's all I got. That's it. That's all you're gonna get. I don't know what the song is. I should know. I thought these AI tools were designed for that kind of mismatched and splotchy memory, off-key representation of music so that it could find you likeness, but it's unable to work with me at all. Probably because it's just not enough information. It's probably not enough information for you guys either, but it's been driving me nuts because that song is in my head. I remember it very well. Nothing. Anyway, what are we doing here aside from just the machinations of a madman? Well, okay, hold on. I gotta go to setup, and I gotta get rid of start soon. We've been taking kind of a turn from our normal projects, right? Burn the subs, always happening. We're gonna get back to it. There's some programming things that scare the shit out of me that I have to do with the Raspberry Pi 5, and then get Python, I guess, maybe running on this thing, but I also have to get C++ to like go into here because of the Project M stuff. For a more computery person, this is probably not that hard. For me, it's just something that I'm ignoring until I absolutely have to do it. So at some point I'll sit down with this thing and a pot of coffee and see if I can get tutorials. I have to go through like 5 tutorials that are unrelated to one another, but will eventually come together to do the thing that I want to do out of this thing. And then we need to get this thing to run Clipper, and then we need to use the Clipper API, and we need to retool all of our Python programming for Burn the Subs so that it can run the new system, which will be running off of Clipper, even though the main processor, the microcontroller on that SKR board is like 32, 64-bit. I don't know. It's like a really good microcontroller, and we're just doing like taking it over and making the Raspberry Pi 5 do all the calculations. I don't know, man. I'm just rolling with it. I guess I can pull a Michael Reeves, and I can basically make a Roomba into an RC car with like an Alexa taped to it, and that is apparently a Roomba that screams. Whereas for me, a project like that would be, how can I take over this robot at the lowest level possible? Maybe I can reprogram it, and maybe I can put in like an Arduino voice recorder that will respond when the input comes through, if I can get into the brain of the Roomba. That's how I do that stuff. And Michael Reeves tapes things to an RC car and makes that into a screaming Roomba, and it is just like a golden, hilarious video. I don't do that. And I need to learn how to do that a little bit more. So for Burn the Subs, in spite of the fact that 3D printer controller that we're using has a really big brain in it, we are going to say, hey, really big brain, solve this crossword puzzle. And it'll be like, why are you making me do this? I can do like advanced mathematics. And we're like, yeah, but do the crossword puzzle. That's sort of what we're going to be doing with Burn the Subs. It's all in here. It's all in here. It's all in here. It's all up here. It's all up here. All the ideas, all the plans. But yeah, I've decided to take kind of a right-hand turn from doing the complicated programming stuff, even though that would get us a lot of good viewers, and do some 7400 series logic things, because those are like a respite. We can relax. We can relax. There's no pressure. It's 7400 series logic. Everything is 5 volts. Everything is in this little walled garden of 5 volt ones and zeros. And in this little walled garden, we can make something cool. Cool thing, Moritz Klein. I stumbled on his videos. I think somebody linked them in the Discord, some of the modular synth people that we've been attracting. The weird beards that they are. Does he have any right to call somebody a weird beard? Look at his beard. Anyway, the eclectic bunch of low-level electronic, knowledgeable modular synthesizer people have turned me on to Moritz Klein's videos. Moritz Klein, I believe, is in some way, shape, or form related to Erica Synths, possibly one of the brains behind it. And the video it's basically a 7400 series logic drum sequencer. So we're doing some unique things with 7400 series logic and sequencing things and remembering things that have been chosen, stuff like that. But it's all with 7400 series. There is no programming behind this. So we can just take a look at what's here at surface level and build it. What's that? I want to ask you, what circuit simulator software do you use? I never simulate circuits. I don't do that. There are some really good online ones that show you like the electrons flowing around. I forget which one that was. That was linked to me a long time ago when I was looking at penis ladder circuits. What did he just say? I said, where's a good example of one? I said penis ladder circuits. If you call it a diode ladder, I don't relate to you, because that's a penis. That's what I see. You've created this tower of diodes for a filter. Anyway, I was trying to figure out how in the hell these things work, because they use some kind of an evil magic in order to create a filter. I was reading Fritzing at the same time that I was saying filter. They use some kind of a dark evil magic in order to limit the frequencies that go through diodes, because as you change the voltage across the diodes, apparently their frequency dependencies shift or something like that. It's mad science, but there are some really good circuit simulators that show all the electrons flowing around everybody. And it was a pretty cool simulator. It was free. You could just throw stuff up on there. That's the last one that I used, and I don't know how any of the other ones work. Fritzing, somebody says in chat. Falstad. Okay, so Falstad is the simulator that I'm thinking of. I come from an era Down Under, where women something and men plunder. Anyway, no. I come from an era where we had LT Spice in the computer lab, and it was all CRT monitors. Actually, no, we had LCDs towards the end there, but it was all like Spice and LT Spice and stuff. And as far as I'm concerned, Spice is a practical joke by programmers against electrical engineers. They say, hey, use this software. And you're like, why are you laughing? Like, okay, let's put a circuit together. And then Spice goes, boom, you can't do that. You go, oh, okay, acknowledge that. I guess I can't do that. Nothing's wrong with this simulation as I put it down. I'm not going to change anything. Let me hit run again. And then you hit run again and it goes, oh, something new. You can't do that. I'm like, wait a minute. No. Close it again. And then you run, and then you click run, right? You just don't change. You don't even click into the program. You click run and it goes, oh, here's your simulation. And you're like, I didn't do anything. Like, was there a sunspot? What happened? Why does this suddenly work? That's what my experience with Spice was. And I said, nope. And so now we do things that I don't need to simulate. Who cares about simulation? I'd rather blow stuff up on the desk. Like the amount of 70,000 views in like a week or two for blowing up a capacitor because I gave a stepper motor controller 50 volts instead of 35 and I didn't check my capacitor voltages. Whereas sitting here with a CAD program and putting in all the specifics about a transistor and then, nah. I'd rather just build it and have something cool happen. LT Spice is the only good one I've used too. Just write the transfer function for your voltage source to get started. I guess, yeah, I mean, listen, let's not be delusional here. Electronics is math, right? And computers is good at math. They do good math. Electronics is math. It all boils down to math. And if you're trying to do something novel, you may find yourself in the realm of math. I love going over analog electronics, but for the most part, when we're doing synthesizer stuff, especially in the analog realm, I have circuits that I know the functions of, right? We use them as building blocks instead of going, I need to amplify this by this amount. It's more like, I'm bringing this into a microcontroller, so I need to have my plus minus 10 volts compatible stuff talk to 0 to 3 volt stuff. And I know the circuit that I need for that. I know the component values that I need for that. That is all math, but we just glossed over the whole thing by just putting in this circuit topography that I know. So, so I do not simulate. What's the meme? I do not simulate, and if I get it wrong, I die, or something like that. I don't simulate. I don't calculate. It's the Remy meme. The what's the guy? Man, Ratatouille. That's what it is. Anyway, yeah, we're not building a penis ladder filter today. I would like to make one of these and have it as a 2 HP module, or a couple of them as a 2 HP modules. But anyway, what we're doing is Moritz Klein's drum machine, drum sequencer specifically. I thought this would have been a very simple circuit and net me like a whole drum machine, but I think the best we're gonna do is have a varied voltage level output as well as like a couple triggers coming out of this thing, right? Because we've got LFO out, accent LED, mod depth. Yeah, there's a couple things going on in here that we're going to manipulate. So we started with the CD4520 that's over here on the left. Generally, when I'm making schematics, I like to go from the upper left to the lower right. So we have kind of a cascade of functionality in our device, right? But sometimes those rules are violated, and so I wanted to start with our clock. And since I didn't have a clock, don't read that wrong. Since I don't have a clock, I have to make my own. And we are in 5 volts TTL logic in the era of the late 70s, early 80s sort of technology. And I capitulated. I had to capitulate. Since we're working with things that don't require programming, and I'm not about to get out the programming stuff, and I could flash an ATtiny 13 in about 20 minutes. It really wouldn't take me long, and then we'd have more scalability maybe of the signals that we're outputting. No, we're going to keep it in the analog-ish realm, and the way we do that with our backs in the corner, no escape, we use a 555. I had to. This is a 555, NE 555. We have a capacitor, we have resistors going up to positive, and the timing of the voltage charging of the capacitor is influencing the initial clock signal. I had to do it. I had no choice. So we put that together, and we put it together in a way where it was just this little blip of a signal coming out of the 555. That little blip of the signal did actually get this thing to do some kind of counting, because the next stage is the CD4520. Now, the CD4520 is what's called a dual up counter. And so the dual up counter has two separate circuits. A lot of these, is there a benefit for analog? Not really, no, not in my mind. No, absolutely not. I could probably make the entire drum sequencer and put it on an AT-Tiny 13 and have that go out to all the analog stuff. It's fun to not have to have programming, right? It can be kind of expensive because the 7400 series, I don't know what point in price range the 7400 series is at right now. It could potentially be expensive just because they're not made anymore. Nobody's using them anymore. Like even the microcontrollers now have logic capable programming sections. You have like a little tiny little piece of an FPGA or a PLC on your microcontroller, because logic has a brutal amount of speed to it, and there's a lot of, we are skirting the very surface of the level of what logic is capable of doing, because there are a lot of logic equations that you can throw at something in order to basically make something that does complicated calculation and programming and any number of stuff. Complicated functionality can be realized using just basic logic, and then when you put your inputs into the basic logic, almost instantly you get your outputs. And this has been instrumental in things like crypto mining and stuff like that, where you want instant results. FPGAs are extremely powerful in my stuff, control systems, where you're trying to have a robot or some kind of a moving element that has a control system behind it, and you need it to do that immediately as a response to some kind of a sensor value, right? So that's where FPGAs fall in the grand scheme of things. That's where logic is still relevant. But for the stuff that we normally do around here, it's like a simple C code with a couple lines in it is just fine. So anyway, logic stuff, it's a little bit obsolete in some circles, so it's hard to find the 7400 series chips, so it may be hard for other people to do what we're doing today. I happen to have just bought on eBay for like $100. I bought a ton of 7400 series logic chips, so why not? Let's do some stuff with this stuff. And the cool part about the 5-volt logic is if you don't understand what's going on with your circuit, you can just drop an LED in, and you can look at that LED flash, and you can go, the LED isn't flashing quite the way I'd like it to. Man, the birthday dinner yesterday was some fatty food. I'm learning now, based on the state of my stomach during this stream. So anyway, what we're trying to do is sequence something, and in order to sequence something, you need to have a counting element to it. And so the counting element in Moritiz's video is a CD4520. The CD is often associated with CMOS levels of logic. CMOS logic chips are a little older. They work off of 12 volts. We have 7400 series, which 74 gives you an idea of what year they came out and were popular. 7400 logic series, 5 volts. It's a nice little walled garden. If you stay in the 7400s, you can keep all your voltages at 5 volts and get away with it. So I found a 555 timer circuit that I thought worked. We plugged it in to the equivalent, not directly equivalent, but the SN74LS93. The 93 is not a dual counter, but according to this, very basic schematic, Moritz is not using the second counter. Hopefully that doesn't come up later. We need a clock. I got the 555 timer on that. And then when we put it all together, it started to do this. And last stream, this is what we were watching, was just like, huh? Why? Why is it doing this? Why isn't it working? And we got some weird weird like counting going on the other pins too. And I took a look at this over the weekend. I sat down at this desk and I said, you know what? I may be in for a long haul session, but I want to figure out how the hell this thing is doing what it's doing and why it's wrong. So I redesigned the 555 so that it had more of a 50% duty cycle. And I achieved that by literally just Googling a circuit and making what somebody else had. They flipped the resistor and the capacitor on the 555. I don't have it up anymore because I was so revulsed by a 555 timing circuit that I decided to just pack it away. But what is that? Anyway, so yeah, the 555 I fixed. So now I have on, off. And I guess that's a little better for the counter. I don't know. But after doing that, I looked up the specific chip that we were using, the 7493, right? Looked that up, 74LS93. All the test circuits that I was finding looked like this, where they would put their clock into pin 14, which is what we have right now, and then they had pin 1 and pin 12 looped. You can see there's multiple circuits here that are just on this page that have that same layout. Clearly, that is not... Why is that one flashing too? Wait, what are you doing? What the... Yeah, so, like, wow, look at it. It's really functioning hard. My God. I looked and looked for a solution. I didn't find anything, and I got frustrated. Well, all right. Oh, yeah, and every now and then you, like, bump into it, and it does stuff. That's so weird. It's like a capacitor that I'm missing or something. So, grab this, just put it right there. And for some reason, it's now counting perfectly, except for the green LED is a little broken. Green LED is kind of broken. I don't know what its deal is. What's your deal? Yeah, I think the LED itself is like dying. This is weird. Anyway, you can kind of see it lighting up. But it's counting in binary, so 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, etc., etc., etc. It's basically filling up the count, and then it spills over. And then it counts all the way up to 1, 0, 0, 0. Wait, 1, 0, 0, 0. It counts up to 8, right? And so 4 bars, 4, 4, music timing. Anyway. Well, I just tested that by poking at the LED. Oh, maybe it's the solder joint over here. Hold on, let's fix this. So poking it with the tweezers is really what tells me what it's doing. Might just be that this side of the resistor isn't really connecting. Try that. Dang it. Why must you betray me? I think the LED might be, or the resistor might be damaged. Yeah, if I short the resistor, it lights up. Probably means I need to pull in a new new resistor, which I don't know where they are. I'll have to find them. Yeah. Oh, whatever. Anyway, we can barely see it. It's not for lack of current in the system. It's just the LED is connected a little funky. So we have our clock coming into this thing. We have our equivalent chip dividing it by binary counting. This would be a count up operation, right? So we've got our count up working now, even though I don't understand why it's not working the way all of the example circuits show it working. It's like, put your clock into pin 14. And I'm like, well, I put it in here and it works. So I'm not really going to question this. Very strange, very strange. Okay, so anyway, that being said, we now have to move on to the later parts of the circuit. We can just put this stuff together. So what direction are we going in? I don't know. We have somewhere, I don't know where in the system, we have a, I guess that's the 4015 is like a cascade carryover bit kind of thing. But all the way over here, we have all of this circuitry, and I don't know what this stuff is doing. Now, again, I could listen to the Moritz Klein video, but that's not as fun as just coming in here and wading into the waters. A genuine what? Wine part? No, they're whatever. Those are just, you know, the 7400 series was before the rampant, blatant, what is it, like knockoff parts. You'd be hard pressed to buy something with a Motorola logo on it that was not directly manufactured by Motorola for this era of parts. Oh wait, is that a big gap right there? Maybe that's what I need to do. No, that's not this era of chips. These, you're buying these, you're pretty much, well, I'm buying them all as a big package. I don't think you're gonna find fake parts like that. What is going on with this? I think it is a bad LED or a bad resistor. Because it really does looks like the solder flows over everything. It's not a bad ground because I pinched the resistor and it showed full current, unless there's under the board maybe. What's going on under here? On the green LED. No, that looks fine. Wait, which one's the green? Second one, lower one, right here. It's all connected. Maybe not, actually. That does look, no, I can see it going around the, yeah, that connects. Nothing else looks dodgy, so I don't know. It just decided that it didn't want to do anything. These were ordered off of eBay, and they are old parts, so I don't think there's counterfeits. I don't think anybody's making a profit off of counterfeiting 7400 series logic chips because nobody uses them anymore. Yeah, no, this just hates me. Whatever. It's probably a bad resistor. It might be that this is severed right here. Weird. Everything looks perfectly well soldered on it. Whatever. Let's not spend too much time on that. I've got these other areas where there's a lot of stuff going on. We have a bunch of different like selectors and things. So what part of this thing are we going into next? I kind of want to get into the what do you call it? The CD 4015, which will do the sort of flip-flop carryover bits that make up the sequencer. It seems like I'm going to need a lot of diodes, and those I only have in surface mount parts. So that's going to be a little weird. Or we get into the op amps. So we got two op amps over here sitting to the right. What are they doing for us? Let's take a look at this closer. So I can read what's going on without it being in a tiny YouTube video. I just took a screenshot of the whole entire circuit. So here we have our quarter notes, our eighth notes. This is what's coming out of Q0. That would just be the clock again. And then that goes up there for halftime. What? Mix and match inputs. Got a trigger over there to hold the bit. Gate out. And then our length selector. There's a lot of selectors on this thing. So over here we have our low frequency oscillator output. What do we low frequency oscillate? Well, I guess we should just build it because we've got an LFO to sync up with the rest of this stuff. It looks like. Yeah, and then he puts an LED on the clock. And then the global clear is related to the CD4015 being a memory circuit for the rest of this thing. We will add more prototyping board to this thing as necessary, obviously. I still use the buffers and shift registers, but not the logic gates. Huh. Buffers and shift registers, really? I guess, yeah, the buffers are really good for systems where you've got like the modular synthesizers style of walled garden, because you have no idea what they're going to be putting into your system, and you sure as hell know that at some point that is going to be static electricity. And so you want, the buffer will at least help in case somebody plugs it into their like their wall. And you get 120 volts in. And then shift registers, yeah, I guess a shift register can be pretty useful. If you want to have a bunch of buttons that are connected to your microcontroller, and your microcontroller doesn't have a lot of pins, then a shift register is exactly what you need. Shift register is what the Nintendo controllers up to Super Nintendo used. They have 5 pins on the Nintendo controller. That's because that's power, ground, latch, clock, and then data. So you latch and your shift register goes, oh, what are the state of all my pins? Got it. And then you give it enough clock cycles, it will put onto the data pin the states of those inputs. So it can serialize your parallel buttons. And so shift register does everything at once, right? So you can do that really fast. You can latch, give it all the clocks, latch, give it all the clocks with an incredible rate. That's how they did a Nintendo controller. Okay, so LFO sync, I guess should we make that or should we do the CD4015 first? Let's do the CD4015. Let's do the 4015 first. We'll do this upper portion of this first, and then we'll build the LFO. So getting into this is the like meat and potatoes of the sequencer. What this is doing is the CD4015 is a, let's get the exact title here. I gotta like, where is 451? That's the up counter, the up dog. I gotta look over here. CD4015 is what they call a CMOS dual 4-stage static shift register. Dual 4-stage static shift register. So what's happening is you're shifting ones and zeros to the next stage. If you have, for instance, the return from a shift register, if you have the serial return from a shift register, you can put the data and the clock on the lines of this thing and it'll reparallelize it. It'll reparallelize it. That's what happens when my insurance gets canceled. It'll paralyze it again. It'll parallelize it and put it back onto individual pins. And this is important for a drum sequencer because it's a drum sequencer. It sequences things. It needs to have a memory element to it and needs to have a sequence of events that it sequences, right? I don't know how many of these in parallel make up the drum machine. That seems fascinating to me. I don't know what's going on here. But we'll get into it as we look into it, I suppose. So we will need a button. The selector, I think I'm going to realize by just using a jumper. And we need a CD4015 equivalent in 7400 series logic. So what we did is we looked up the list of 7400 series logic gates, logic chips, and we figured out what the landscape was. I'm getting rid of some windows that we really don't need. And I believe what we found was the one that's sitting in front of me that I'll get in just a second. Hold on one sec. Oh yeah, here's the alternative 555 circuit, I think. No, I didn't use that one. Either way, the 555 has like a pull-up resistor, It has a capacitor going to ground. It charges that capacitor and outputs. And so this is where the variable resistor is now. I don't know what that does. It just did something with the value, the component values that I was using. CMOS dual updogs, no. List of 7400. So we looked through the list of 7400 series logic chips, and we found something with the same name, because all the same chips exist in CD series and 7400 series. There may be a few exceptions, but mainly the 7400 series moved CD logic into the 5-volt territory. And what I found may shock you. I can't read that. The TL07, oh no, that's an op amp. This one over here. 74, believe it or not. LS, believe it or not. 164. The 164 is a data sheet that I'm totally not pulling up. 74 LS 164. I used to own a Volvo 164. Has nothing to do with this chip, but I used to have one. 8-bit parallel out serial shift register. Now, the thing about this one is that it is a full shift register instead of 4. I do not know how Moritz has his hooked up. I don't know how it's hooked up. So we need to double check that. We need to make sure that like our CD dual 4 is connected to itself. And that's just something that we'll compensate for. So let's take a look. Hold on. Let's take a look at this thing. 4A to DB, you sunk my battleship. This is a sign. This is a sign. I think. Hold on. How does this thing work? What's your pinout? What your pin's doing? There we go. Let's get closer. Let's get closer to this. Let's make it enormous because we have terrible eyes. 242. Wish I still had it. My uncle still has his 1977. His 240. Yeah, he still has it. It is so rusty because it's up in the Northeast on an island. But it was when I was a kid. No, I was in college. He drove it to our place in Pennsylvania, and oh my God, it was a crazy car. My family's been a Volvo family forever. I've gone to be a BMW nerd just because of the availability of all of the data on those cars. But my brother has a P1800 ES, and I had a 164 as a kid, as a teenager. That is the worst car to buy. A teenager, it's neat. It was cool. I don't know if it made me cool. I was always a complete nerd. And that was back when it was very much not cool to be a nerd. It was really just wasn't a good idea. And the 164, the thing about it is that right at the firewall, you change from metric to English bolts. So what they did is they took a 240 and they took the whole front off, ahead of the firewall, and then they gave it a fancy front and they gave it a leather interior. And they said, done, this is a luxury car. So I, as a teenager, had to build up a very large tool bin in order to keep that car on the road. Although generally to keep a Volvo on the road, you pretty much open it up and you hit it with a wrench. And if any of the cracked pipes let fluid out, you fix that and then you're done. That's it. That's all you do. So anyway, 4A to DB. My battleship, 4A to data B. Pin 10 to pin 15. These are not numbered. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So indeed, we are configured like the 8-bit in that D goes into the data of the next one down the line, right? So, in fact, we are realizing Moritz's vision in a more succinct way. We have one less wire. Ah! Next, police Volvo 850R Estate was tuned close to 400 brake horsepower, solid car. Oh man, there was something back in the old-timey days of the internet, way back in the day, that my brother and I found, where some crazy person, this is only be defined as a crazy person, somebody put a big turbo on the 164 iron block, and they got a lot out of it. And I was always like, I should get a turbo in this car. Your first car was a luxury car. Let's not get hung up on labels. This was a barely leather interiored Volvo with a fancy front end. That's it. And it wasn't even that fancy looking. Volvo 164, luxury. You know, like it was an old car. And also when I had it, it was pretty old. Yeah, my brother had 850s for a long time. Fun cars, weird to tune them. I didn't do like any engine tuning. It was usually like you get a big roll bar and maybe some Volvo speed accessories for like $1 million. I had lowering springs on my 164. They were like, this might put the bumper a little bit below the legal limit. And I'm like, nobody's got a ruler. Like, I had to wire money to Sweden. Okay, so we can hook this up pretty much in the way that Moritz intends. I don't know what any of this stuff is doing, but it should be fun to mess around with. Pattern length is done by a feed to 1B and 2B. 1B and 2B are where on the grand scheme of things. Okay, so to get our 7400 series logic chip into our walled garden where we can do no harm with the ones and zeros, we need to hook this thing up to its power and ground. And so we got our basic pinout over here, which differs from the CD 4015 because this is a 12 volt system. It's probably easier to work with the CDs, but whatever. And pin 14 and pin 7 are typically the power and ground for your logic chips. So we can I'm going to throw this thing down with just a little bit of space over here. I don't know what we're doing with the LEDs, and we might unhook the LEDs actually. Although keeping this stuff right here gives me a better like jumper selection for the timing. So maybe we will keep this. Okay, that's not moving, so I'm going to leave it there. And then, because we've been doing this stuff for a little while, hold on, I gotta go over here in the other part of the shop and grab this thing. $10. $10 for 5 of these kits. I got a little fed up with looking for exactly the right kind of jumper, and I don't like working sloppy when I'm on a breadboard that is this complicated. Things cascade and tend to get more and more complicated, and if your work is sloppy, I've seen some engineers, just some electrical, some budding electrical engineers just throw everything down onto the solderless breadboard, connect it however it needs to be connected, and then they have a big bird's nest of wires here, and they go, of course the circuit works, and they have to kind of like jiggle the wires to get it to run. I do everything low and tight. Everything is low to the board and tightly configured. Areas where we jump from one circuit structure to the other can typically get sort of an outside jump like that. Inside jumps I try to limit, like this is a little bit sloppy. I would like to have it sort of go down and over, but it's all just communication, right? And if you keep it tight like this, you can pack it up and you can throw it in a bin and it'll come back out of the bin and still work. How's a bad boy? Tuning cars, painting the classic mini engine block. Red. Oh yeah, red paint, of course, does add, yeah, it adds horsepower. It also does make you visible to the Ben Eater method. Is that what he does? Oh man, there's some good projects that Ben Eater's done. What's why is it like a, I thought that was tape. Small the sickle flames from Car Magazine's awesome. I've not had a classic Vinny with over 100 horsepower, but I have a dream. Oh, don't look at Project Binky. That's a good solid amount of videos to watch. Yeah, Binky is one of the reasons I've got such a heavy itch for the 944 project. That's why it's eating away at me. And the problem is I had a Burgundy 944. I sold it to a Grassroots Motorsports Challenge team for like $2,000 many years ago. I've moved. I don't have a garage anymore that I can call my own. Very sad. I would very much like to, wow, this wire's cheap. I would very much like to get to that project, but man, I don't know. Maybe someday we can always hold out hope. And especially because the content would be pretty popular, eh? I think it would be. Might actually get me a third viewer. Here, let's unhook power while we're building this circuit so that we don't have weird stuff happening. And then we got to go to ground here. Pin 7. Wait, why are we? This one's facing this way. This one is facing this way. Okay, so we're putting pin 1 over to the right. Let's put pin 1 over to the right. I got to get under it with the tweezers and then horizontally twist the tweezers so that I'm pulling out evenly. Something, pull out game strong. I've heard them all. All right. That goes in there. And of course, the pins are too wide. So you either have to force it in a weird way, or you can come over here and just give it a little tweak. I do this because the table surface is even and I'm bending all the pins at once, so they end up relatively even to one another. A Datsun 100A, the My Summer Car. You get 5. I'll get all the My Summer Car viewers. They're pretty loyal. Buddy of mine recently had a Datsun. It wasn't a 100A. I forget which one it was. It's the good one that everybody modifies and puts fender flares on. It was white. And then I looked at the Project Car subreddit, which I should never do. I'm not allowed to look at that subreddit. And I looked at it and I saw somebody had a very similar car to the one my buddy sold. Oh, the 510, yeah. One day I'll be able to post on that subreddit. We used to do the Big Apple to the Big Easy rally, which is sort of like those British road rallies where they go through a bunch of countries and have to do like little challenges and stuff. We did the Datsun's a name I haven't heard in a very long time. Datsuns are awesome. They are great. We used to do the Grassroots Motorsports, not the Grassroots Motorsports Challenge, although some of my friends have done that, and 24 Hours of Lemons. But the Big Apple to Big Easy rally we used to do, and it was a crazy time because it was like a big rolling tailgate, and everybody was car guys, and so we all wanted to keep the cars moving, keep them moving along. So everybody would help everybody get to the next, the next hotel, the next cheap motel, where we would have just like a little tailgate party. Okay, so I hooked it up to power. Now what? RA and RB are what equivalent? RA and RB. Ra and RB. So the R pins are the clear bit. Wait, but how are we clear? I thought that we'd be clear with the clear button. This thing, global clear. I guess not. It's on DA. R and D. D is going to be specific to the 4015. Data A, reset A, data B, reset B. data B is coming from data A. Clock B, reset B, CB, all the way around to clock A. So clock A and B get the same thing, and they get either an external clock signal or what's coming from the CD4015. That's weird. Okay, so why is that halftime? Oh, because it specifically goes to Q0. Wait, that's the normal clock. Duh. Huh, I'm already confused. We're not in the US. I mean, we have Alfa Romeo in the US too. Had a friend who's no longer with us who kept Alfa Romeos, and he had the coolest garage ever. Basically, he had like a really nice house, and you would walk behind the house, which was just like a big hill, and there were like chicken coops, and then next to it there was the garage, and it had dirt floors. So when he got these extremely fancy Alfa Romeos in and out of the garage, he had to put boards down and stuff and take it over the lawn in order to drive them around. And it had a dirt pit. It did not have a lift. He had a dirt pit. I should have cozied up to him more, gotten an inheritance. Okay, so our main clock is coming out of here, and it's going to this pin, but then at the same time, that's for the LFO syncing. So all of the quarter and half times are on the LFO sync. What the? So we're just taking the big boy clock, and we're just taking it all the way over to here. And I don't really know, this would be the main clock, and then this one goes to Q0, but Q0 is the same, because it goes 0, 1, 2, 3, which is not halftime, because if we power this thing back up, we can see it counting. Now, obviously, you guys, this is a lot of bother interprets this, right? It's a bother interprets the circuit while not paying attention to what Moritz Klein built, because they are far superior at building things than I am. It might be that it's supposed to be going to B. A 164 is a single 8-bit register, but a 4015 is a dual 4-bit. Yeah, but that's what we just confirmed, is that Moritz is connecting the end of this register to the beginning of the next one. So he's using the dual registers and just putting them up against each other. Our chip already does that, which is why I'm looking through the individual pins to see what they're doing. So our chip is configured in the same way as this one. I'm just wondering about these like half timings and stuff, because somehow in their circuit at Q0, is Q0 half time, this clock being the same as this clock, Q0 should be lighting up at the exact same rate as the other clock. Or no, it's looking for the edge. Wait a minute. It's looking for the edge, so dude, no, but these are directly in sync. Like this would be half time. Our output B. Quarter notes is going to the LFO. We don't have to pay attention to at the moment. I'm just looking at. So I feel like half notes output is the B channel here, because obviously the LED is going half as much. This one, the green one that we can barely see, is on for half. And I guess that's what we're using. Strange. Okay, so all of the pins in this bin have just they all left. It's just empty, and now they're all over here. All right, anyway. It's a new jumper kit. So I guess, okay, so we'll just inject, and I'm going to do this with a wire because this is a switch. So the switches, because I don't have an abundance of switches in the shop, I'm just going to put a flexible wire connection to, so it'll be like sticking up, and we know that it's something that can be reconfigured. Hopefully we remember. this is not the right jumper kit. Well, I should be able to find one. Actually, is there one up here? Yeah. No, there's not. By the way, with the dog collar project, I've pretty much wrapped up all the changes that I want to make in there. We need to get that into the programming and load it up and see what happens. If we don't need to give it a couple outs, that'll allow the program to still function when we've disabled Wi-Fi. We're putting it into a specific sleep mode, but then I've got to directly program those sleep modes, and the button code for WLED is not well programmed, in spite of the fact that the programmers would tell you that they did it exactly right. It is not well put together. It is quite sloppy programming in that area. But that doesn't mean that we can't come in there and alter it a little bit. I'm not going to do a whole like git push and clean up all their code and refactor it and make any goddamn sense. But they have, as a 10-second button press that they didn't mention anywhere else, a factory reset. So if you hold that button down for 10 seconds, the thing factory resets, which means all of its pins get put onto different pins. And so if you have a button on that special button, again, the only button that we have access to and are able to change the stuff on, if we have the button connected there for like a portable device, or we have it happen to be connected wrong when you're prototyping, it could theoretically be held down for 10 seconds and interpret that, and then you do a factory reset. And I don't know, that could eventually lead to breaking your device. So it's a little weird. And then also the sequence that it has is very strange. So all right, anyway, we are connecting this to what is clock A, or in our case, clock. We just have one clock. So the clock is coming from pin 8. 1, 2, 3, 4, actually 35, so 36 minus 8. 1, 2, 3, 4, 5, 6, 7, 8. This is one. So this is our clock. No, wait a minute. I think I'm powering this thing backwards. Wait a minute. Pin 1. No. This is how you blow up 7400 series logic chips. Although giving it 5 volts, they're usually pretty robust. But this is where power's supposed to go. This is where ground's supposed to go. Everything we've hooked up is a lie. Where'd my tweezers go? Oh, they're over here. This is sometimes we hook things up wrong. Pin 14 is VCC. Need a longer jumper. The CC. Now, these are cheap jumpers. They're $10 for the 3 pins. So they're not very good at plugging into. So my main man. Like, this is going to be very frustrating. I used to have this jumper kit that was older, and it had this big pair of tweezers that had the little grippies on the ends, and it was perfect for this kind of stuff. And it used slightly better wire that could actually stick up for itself instead of just folding at the first sign of resistance. This one also needs to be longer. I could have used shorter jumpers if I went with pin 1 facing the other direction. Okay, so there's power and ground to pin 7 and pin 14, typical of 7400 series logic. We've got our clock signal coming from our halftime, which goes on pin 8, which is this one. So there's that. This is so that you can change it to be regular clock time or halftime. I'm not certain about that one, but I'm doing it just instead of putting a switch in. Then we've got a lot of stuff to hook up here. We do not need to do 4A to DB. RB connected to ground, RA connected to ground. R is enable. So enable, B, and A are connected to ground. Do R's work that way? It is inverted So we want it connected to ground. Yes. Okay, so the clear bit is inverted. I guess he's not using the clear bit because they're not hooked up to anything else. So RA and RB are just simply our clear bit. What pin was that? It was pin 8? No, pin 9. Pin 9 connected to ground. Grab a jumper. See, this the 8-bit register is actually simplifying our circuit in a few ways. Not in any really meaningful ways, but it is simplifying it in a couple little facets. A couple little aspects are maybe just slightly simpler. A, B, C, D, E, F, G, H. Okay, so those are our outputs. And then A and B. What are A and B? When so in the grand scheme of electronics, when there is a line over whatever the pin is, so we've got down here, we have clear has a line over it, that means it's active low instead of active high. So clock, active high, you send it a positive signal, it reacts. You can see they put it on inverters and then they have it coming in and they have got these little inverted inputs with a little arrow on it. Line over it means active low. On the CD4017, they are not active low. Okay, so we'll tie them to VCC then, because ours are the opposite scheme. They don't have a line over them. That's easy enough for me to implement with a singular jumper. Yeah, that would have held clear. We gotta watch out for that. Remember, we're not using the same chip. So our clear bit is now dealt with. Wow, we got a lot of stuff going into this part. 1B, 2B, and then 1A. How does, wait a minute. Oh, 1B, 2B, and then 1A. What? How is this a sequencer? I guess as they pass by these locations, we get our lengths. So 4B is all the way at the end. And then these are shorter sequence lengths. So we're gonna start with 4B. I think that's the one that we're gonna be using is the end one so that we get the full sequence length and we can actually see what's going on here. It'd be fun to put these all through LEDs though. I guess we do kind of have room to do that. And then data A held down with a 100K coming from the clock lengths with a diode triggered by, what the hell is that circuit? Global clear mod. Does it just clear out? We got trigger and then clear. Trigger is grounding this part of the circuit, which doesn't interact with anything. Wait, what? Wait a minute. Oh, so trigger for that would come through. That's global clear. Don't have to worry about that. So clock on the downbeat comes through here and goes to 1A. That clock signal goes everywhere, doesn't it? Clear B line is tied to one of the stage B. If you want the full schematic, you check out the YouTubes and open up Mortiz, M-O-R-I. Let's just give you the video. Put the video in chat. In Twitch chat. Sorry, YouTube. Boop. Boop. Where the hell's paste these days? There it is. All right, there's the video. So this is the grand scheme, like I should have watched this video again before I did this stream, but I figured it would be funnier to kind of struggle with the circuit to get through it, because we're doing weird stuff to it already. We're taking the 7400s, the CD series, and replacing with the 7400 series, which is a thing that's done. I remember this was a Hackaday project a long time ago. We're following Mortiz Klein's schematic. They are much smarter than me, and their video is laid out in an extremely easy to follow way. So I would suggest you go look at that. But that's not what we're doing. We are struggling through the circuit, and I'm trying to see if I can figure out what's going on. Because I watched that video several times, and it went in one ear and out the other. And so I am basically rubbing my nose in this until I actually understand what the hell's going on. Because logic stuff is fun, and we can kind of we can all fit on the struggle bus. It's a very big bus. Norse Herald is the new top clipper with 5 views. What? 4 days ago. What were we doing? I wonder what that one was. And then Rabaz gave me a shout out earlier. That was nice. Other than that, there's been no activity. On this, the day of my birthday. Okay, sitting back down. I had to do a little bit of movement because I was getting cold. So basically, this drum machine rolls through the sequence at a clock rate, right? You have a clock that's going doot, 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 doot. That's if you're doing 4/4. Doot, 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 doot. And then you can trigger it by holding down the button. So doot, 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 doot. There's a trigger here, right? How does that work? Well, we're putting data into the shift register. And so when you've got the trigger activated, it supposedly puts a 1 or a 0 on that thing. Happy birthday. Thank you. Yeah. Not a very eventful one, but I didn't want it eventful. I'm going to need some diodes. I've got some 1N4148s. I don't have through holes. Not having through holes is very annoying on the solderless breadboard. We can make a couple diodes basically by soldering stuff together. So I'm going to make the 3 diodes that I'm going to need for this sequence. Do I need any more? Looks like only 3. Where's our output going though? It's a gate signal, so it's just supposed to be like an 8-volt pulse, which is baffling because it's hooked up to an op amp. But I guess are we gonna have to introduce 12 volts into the circuit? We might. Well, we'll just observe it with an LED at first, and it's possible that the 5-volt signal would be enough to set off some equipment's gates. So yeah, we'll just go from there. I don't understand this putting the clock, if that signal flag right here, clock 0 to 12 volts, coming from 1A, because the sequence, I guess the sequence is at 1A. But then it cascades all the way to 4B. Because we go 1A, 2A, 3A, 4A, 1B, 2B, 3B, 4B. And if we can get that working, then we can put the sequencer into some LEDs and we can just see it operating. See it carry the bits over. Which, you know, in that case, length and trigger and all that stuff, I don't know how much I really need to lean into them. But we're going to need some PNPs and NPNs too. Let's get the diodes together because that'll involve a little bit of soldering. So I'm just going to unhook power, come over here, and get my pin headers. I have a whole bin that's filled with pin headers. The way that I do diodes when I don't have a through hole, because through hole diodes are fairly fragile. They're glass body diodes when you're working with stuff like this. And, you know, you bend them wrong and they break. The glass breaks. I appreciate my epoxy body diodes, and the 1N4148 is what would be called a jelly bean part, which means that everybody has them. I don't know why everybody has jelly beans. I'd rather call them asshole parts because everybody has an ass. Well, most people have an asshole. I think I know a few people who don't have one. They are assholes though, so everyone is an asshole. So that, you know, that maybe that's what we should be calling them, is asshole parts. But I have surface mount 1N4148s because I hate through hole. I don't know if you guys know me, but I hate through hole. I hate them. We got 5819 shotkeys, just shotkey, dual shotkeys. We want something like a 1N4148. I better have a lot of them. I got a couple of them. I think that might be enough. We need 3, right? So female header, and I use the female header just as an adapter. so that I can solder the diode on top of it and then plug it into the breadboard. They're not the best connection because these are not big square headers on the other end here. They tend to pop out a little bit, but if you kind of nestle them in, they'll stay in and give you a decent enough connection. It's not exactly the best cheat code in the world, but it does work. La la la, trust us. Okay, 3 of these. Ooh. Oh, I'm so glad another song is stuck in my head now. Actually, I can still pull up that other one. Yep, there's the other one. Damn it. Son of a bitch. Yeah, his clock signal is 0 to 12 volts. Ours is 5. So we have to deal with that. But it looks like he's injecting the clock into several places. The one that I don't get, Tater, is this one over here. We've got our clock signal coming in here, but then we've also got the clock signal coming from Q0 of the CD4020, the counter. Q0 of the counter is the clock. It's, well, according to the way that I hooked it up, it's just the clock. So maybe that's a little different for his circuit. Maybe we need to be using QB as the halftime clock. Because I think that's what it's meant to be, is this down here is halftime. So in our system, we would have to hook it up to what is essentially Q1. That's how I'm interpreting this. Yeah, what this is. This over here, the count up device is providing us with, and I'll have to, you gotta look above chat, but from here to here, that's one time. This is half time. I don't know what that one is. Divide, they're all divide by. The green LED is hard to see. We don't know what's wrong with it. It's something with my resistor. But yeah, that's the halftime clock that I think is supposed to be on the other side of that switch. And then this is the 1-to-1 clock. Okay. These like barely make contact. It's not great. Yeah, that's we're counting, but that's also clock dividing. There is ice cold air like only on my pants, and it's kind of weird. Like my legs are cold. Obviously you guys see me wearing flannels every day. I like cold weather, but this is a bit much. I need to buy like a warehouse in New Hampshire and just stream from there, as long as Amazon's nearby. I need my supply of plastic bullshit. It keeps me from realizing how awful my life is. That was a nuclear-powered burp from leftovers from eating out last night. Whew. I barely kept that one under. Volcano diverted. All right, so here's what I do for surface mount parts like this. I will. That's the wrong end. Wrong end. That's the wrong end. Wrong end. Wrong end. I will solder these little cups that are supposed to take a pin in them. And pin headers, you buy them by the bushel, and you go, holy crap, I did not know those are so expensive. And then from that moment out, you treat them as if they did not cost anything. Headers are disposable. So what I do is I load up the solder, the cup with solder, and of course I plug them into the breadboard because the breadboard will sap away the heat, and it'll keep these pins from melting into funny angles that don't fit in the breadboard. So a little bit of solder on one of the pins, and then we pull in our tiny surface mount diode. In spite of their stature, these things are more robust than the glass body diodes that I despise. I mean, they're a little less compatible with, you know, breadboarding. We can get by with these. The only thing that I don't like is that I can't label these little add-on parts, but I have a diode and transistor tester that I can use to characterize them. Because yeah, which one's pin which one's the pin with the bar? There it is. Gotta use the microscope to see them. Yeah, and oh, so the music nerd, somewhat theater nerd, festival nerd, is pretty excited about certain shows that are coming out, and so the songs are stuck in his head. How can you blame me? It's not anything you guys shouldn't expect. Let's flip that. Okay, can we? No, apparently not. Apparently not. I gotta get Willow's collar done because we did daylight savings time and now it's so dark out when I take her for walks. I have that secondary one that I bought that still works though. But the thing that I'm sort of machinating about doing, the thing I'm thinking about is getting it into a partial sleep mode where it doesn't do Wi-Fi. That one commenter when we were talking about WLED stuff, that I don't really appreciate is when they get very aggressive with the idea hose that I bring to chat. Because, you know, we don't know nothing about nothing. We don't claim to know anything, but we are also an unfettered mind. And so thinking about putting it into Wi-Fi sleep, we do not stop when we say, oh, but then it won't function, right? Instead, what I did is I tried one of the ways people got it to go into having no Wi-Fi. This is by not assigning an SSID and a password, right? That should have gotten it to be like, well, I guess I'll shut down the Wi-Fi now. That might have worked, but the whole microcontroller was bricked at that point. And I think I eventually initiated a factory reset on it by accident. So what we need to do, we need to go in, we need to look at the button mode code, the mode code. We looked at the button mode code, and what we need to do is we need to change it around a little bit so that, first of all, there's no factory reset mode. It's stupid. If I ever need to do a factory reset, I'm just going to reprogram the whole microcontroller. Because I think the WLED is not designed for our level of fuckery that we're able to do here. And I've got the whole thing functioning in Platform IO, so I can alter it to my little black heart's content. Come back. And so we can get rid of that mode. We can build into the 6-second AP mode, turning back on the Wi-Fi. So we can have it turn on the Wi-Fi. Maybe then at the 10-second press, we'll have it do AP mode. But for the initial Wi-Fi, we can have it come up and look for the SSID and stuff. I think that should be pretty easy to do. And then we'll have to look at what is keeping it from functioning when it doesn't have Wi-Fi, because it might be dependent on certain systems being active in order to... You think you see what he's doing now. Feel free to explain it to me where I haven't really understood what was going on. Because I did watch the video twice, but I think it was mostly on in the background when I did watch it. And I thought it was fascinating, but a lot of it is leaked out of my ears by now. Yeah, that's the dog collar stuff, and it always takes on way more complexity than it really needs to. But I think we'll really be able to do some good stuff with it. And then eventually, when the C6 ESP32 is available, I'll have to go back and do all of my same edits to new code, which is very annoying, and it's not the way I wanted this thing to function. But I don't think I can make a user mod that'll do the stuff that I want it to do in their system. Like, maybe I could. I don't know. Is that possible? I'd have to learn how to user mods work, because it would be nice if it was just a user mod, because then I would just be responsible in doing some if-def statements that'll categorize things and, you know, get all the right pieces of the code into the right pieces of the code. So that's 3 diodes. Not the best work that I've ever done, but they are there. So 3 diodes. We need a couple PNPs and NPNs. Now I happen to have a couple kits of through-hole PNPs and NPNs, although I do like using the ones that I put on these little cute little standoff circuit boards. It's nice because they're actually labeled, although the labels are not accurate depending on which ones you do. I think it's better that I just put a bunch of cans down. I just put a bunch of the through-hole ones down because we bought them. Might as well use them. So what do we need up here? Now, there are no parts labeled for these transistors, right? I am going to assume something like a 2N222 or a 2N3904. Those are, again, jelly bean parts. They all do just about the same stuff in this kind of circuit. They're used as just like a switch. And so we've got a couple of them running in a couple different ways. I would like to kind of figure out how this is doing it. Thinking about it on a circuit perspective, we've got the length selection going to the different cascade flip-flops. Flip-flop, flipping and flopping, just flipping pancakes over to the next thing, right? When these mofos over here, where are we? Why are you clicking weird? Oh, my seltzer bottle was holding down the control key. All right. This is a better way to look at it. Even though it's sideways, we'll all have to just go into TikTok mode to see this. What's happening here? We have an input. An input comes in to either of these locations, right? We have a clear bit that wipes all of the ones and zeros. We're not using that. We have a clock. As the clock goes from 1 to 0, the flip-flops flip their flop. And so whatever data we've got on the input gets flipped over to the output. Now, Bob, that sounds a lot like memory. Yeah, it is. It's actually a very rudimentary implementation of memory, which is why we're using it in the circuit, because this remembers what our sequencer has programmed in it. So we're flipping and we're flopping, and we're moving our ones and zeros all the way down the line, and we can take a look at the ones and zeros anywhere on one of these outputs, and then it finally gets to the last output. Where's the carryover? There is not a carryover. There's no carryover on this. This is just what this system is. Essentially, if you wanted to put something into a binary decimal encoder or some such piece of technology, and you had a serial signal, for instance, something coming from what I described earlier, shift register. You have a bunch of buttons pressed on your shift register, and you want to put them back into parallel and have them do something, I don't know. You would then send the clock and the serial bits into this thing, and it would reorganize them so that they were on parallel lines. But in our case, we're using it as a sequencer, so there does have to be some kind of a carryover here, and that's, I think, what we're configuring with some of these different outputs from the other chip. I have so many windows open right now that it's very confusing to me. So I guess we'll start with our halftime clock. And that goes up to CB, clock B, and clock A. So clock to clock. Oh, I already have that. That's what the wire is. Derp. Okay, so we got the wire there. That's fine. We got that. The ground connections we got. The power connections we got. 4B to diode. So 4B is the last, the very last piece of the sequence. So 4B translates to QH, which is pin 13. So we need pin 13, 7, 14, pin 13, and then I need to just skip over one pin there so that I can throw my diode at this thing. Let's put this up here. Solder goes up there. Basically need a 1-pin skip, which I don't think this is. La la la, trust us. So the function of the diodes is a check valve. It's you know, as much as I hate that analogy, because it's everywhere. Electronics is water, and everything's a check valve. A diode is a check valve. A transistor is a check valve in your water system. It's not a water system, but that's what everybody does. That's the analogy everybody uses. So in our waterway, if we want to make sure that current doesn't flow backwards on something, so we keep something charged, or maybe we discharge something properly, we put a diode in there. Oh, this new breadboard, the clips can fight you. All right, so the diode, it is an arrow that's facing a line. In the schematic, the line is the same as the arrow on, 99% of your parts. There may be one super frustrating manufacturer that doesn't follow the convention, but this line here represents the line on the part itself. And you have an anode and a cathode on a diode. A plus, C minus, that's the orientation of the plus and minus on the diode. What's happening here is current is being allowed to fill this collector for the transistor. So this is a PNP transistor, so it's a high side switch, switching power down into the next part of the circuit. So when this switches over, current will flow, I guess, down here. I don't think it'll clear out. So what's happening there? That's kind of a weird. So I guess this side of the diode is being brought low by the flip-flops. And so this is just keeping, I suppose it's just keeping current from backfilling, you know, up into something. A little weird, but we'll implement it. So 4B goes to the diode, which then goes to a transistor. And so the diode's line is facing away from 4B. So this goes like that. Easy peasy lemon squeezy. We're doing good so far. And that's a 1N4148. Which should, in theory, work just fine. All right, where are my transistors? Where'd those go? I've got a couple of them in this bin, so we got to hunt for a PNP. I think it's 3902, 3906. 2N. What is that? 78? Something? No. Shouldn't be. Hold on. I need to make a little bit of room here. Put some parts away. The temperature gradient in the studio right now is very strange. Is it a 7,000? Yeah, it is. What the hell is a 2N7000? I've never heard of that one before. This used to be a transistor kit, but now it's just sort of this derelict bin of all of the breadboarding stuff. Like when we're done a project, believe it or not, I just toss all the stuff into this bin. And this bin originated as a party, like a gift bag that my viewers, the 5 or 6 people that were watching and kind of dedicated back in the day, they sent me a bunch of stuff that I don't have. And so part of it was things that they saw that I was missing, like through-hole transistors. So they sent me a little pack of them, and I still have this. So 3906 is which one? That's PNP, right? I'll just look it up quickly. Yeah, my upper half is overheating and my lower half is like freezing cold. Am I gonna die? It's because the fan was on my legs for a long time. Set your home address to find places near you. Ha ha ha, block. Jeez. Wait, oh, is this the Google window that I opened, or is this still Firefox? This is Google. No, this is Firefox. Yeah, because I'm not signed in. Oh, I see. So it's not actually a transistor. 2N3906. Sienna, I'm gonna 2N. General purpose transistor. So this one is the p-doped one. Why do they do that? Why do they flip the arrow to be underneath? Very annoying. It's a short poltergeist. What, that I'm sitting on their face? What? No. Yeah, it's arrow in, arrow out, right? And the arrow in is always on the upper plus side. And then on the data sheet, just to mess with you, they flip it. Why do they do that? So the 3906 will do just fine. All right. All right. Ever confusing the transistors. You'll see that in any modern data sheet, they have a 3-dimensional drawing of the transistor. Back in the day, this stuff was so confusing. You had to flip to the other side of the board, and you're like, wait, which end is which? And you just don't know, and then you hook it up wrong, and then it breaks, and there's no indicator that it breaks. It just stops working. So anyway, pin 1 is our emitter, even though it's technically should be collector. Hold on, I gotta pull up the thing. How many of those do you have? So the diode goes into the emitter, which is pin 1, which is this one. So simple as they go. I put these, I don't really cut the length of these, I just kind of put them down. This is kind of annoying. Oh, and then the clips fight me, of course. There it goes. Okay, so there's a transistor. So the middle pin is the base, and then the collector on this one goes to the next part of the circuit. So this circuit, and then our emitter goes to data A, with the 100K pulling it down. Okay, I was wondering how this thing returned back to ground. This is a very busy schematic. I probably would group things a little differently, but it's probably what just fit on the page. But this 100K is actually what's returning everybody back, because when you have this thing flip up here, when the clock flips, this will still have charge on it. And if it's allowed to go down here, then this is still going to have charge on it too. And this isn't inserting anything, and it's blocking in the opposite direction, so all of your charge here goes down the 100K to ground. I see. Okay, so data in is the pin that we want, different than the CD4015. So data in on you, pins 1 and 2, but they're ANDed together. Wait a minute, how's that work? Pins 1 and 2, this and this. How do I deal with that? Interesting. Well, I guess I could just hook them up to one another, because then they're both, right? This and this. And if they're both 0, then it should go 0, and they're both 1, it should go 1. So yeah, we just need a one thing jumper. So the output here has a 100K to ground and a jumper to its neighbor. Rather pin 1 and 2 over here. Okay, so let's find a one thing jumper. A one singular thing jumper, which I have. I keep seeing them on the desk, and then I can't find them. Let's use this one. 1 and 2. Those are now physically ANDed together. Wait, AND gate 0, 0 is, hold on a minute. Boy, do I not need AI to tell me that. Okay, 0, 0, 0, 1, 1 is 1. That's all we need. This and this. Yeah, these are the star of the show when it comes to logic, like 7400 series logic. And then when you really get into it, there's a whole like systems of equations and laws and rules that you can use in order to make the logic stuff do things. You can come in and say, oh, due to this law here, I can make these gates into this and reduce this to this. There's all kinds of cool stuff that you can do with logic. And then getting even deeper into it, you can have an FPGA where you can literally just emulate an entire processor using that stuff. So the emitter here goes up and over to our little AND junction, which is using up a lot of the board that I really wish I could get. It's not really looking good. I guess I could jump over with this. Where's the base going? We could jump over the gap with it. Where is my... There it is. The base over here has a 1M to ground, and then it does a bunch of other crazy stuff involving the trigger. So I want to maybe keep that on the lower part of the board, but okay, so DA is a data A, and right next to it is another diode. So I'm going to keep this clear. because data A, the diode goes bar in, goes here. So then that's the other side of DA, which gets another transistor. All right, so maybe I do want to stay out here. There's so much going on. Okay, so 100K on this one to ground, which means I need my resistors. Or I find a 100K up here. If that boy could read color bands, he'd be real angry right now. Let's see here. Probably have a derelict 100K just sitting around. $180 ohms. Dang it. 9K. Come on. Hold on, let me get my mouse back. Derelict parts. Floating around. Come on. $55? What the heck was I up to? I don't remember any of this. $1K. Nah. One of you is 100, I know. Has to be. Not just one, it's probably multiple of them are 100K. Finding a lot of 1Ks. There's 100K. All right, you come here. So 100K to ground, so we don't need it to be this long. I can just bend these directly down next to the thing and cut these again. Cut the leads again. Yeah, it's even with the length of the resistor, it's a little long, so I'll just have to jump in more than I'd like to. There you go. Okay, there's the resistor to ground. We're slowly putting this thing together. The base of this transistor does all kinds of crazy, crappy stuff. It gets a 1 mega ohm resistor to ground. That is a very weak pull down. That is a very weak pull down. The weakest of pull downs. So 1M, we don't even use 1M a whole lot here, so let's fish for it. We should have plenty. Come on in. 1M. Or anything close to 1M, because these resistors, this kit has been picked through. There's a 2M. 1M5, and then 680K. What? These are out of order, aren't they? You're out of order. 4M. 3M3. All right, I guess we're doing 1M5. I don't think 500K is going to negatively affect this thing. Never know, though. Maybe the triggers won't be quite as crisp. But I think 680K is so far from that it's probably not the right choice. So I probably want to keep it in the 1M range. My tools are doing this dance around the shop when we do this kind of stuff, because I'm like constantly like, oh, get this out of the way, put this over here. And so I'll end up losing them quite easily. And sometimes it's just lost in plain sight. Well, we should get the multimeter. Put that over here. Out of the way. So the base goes to a 1M that's pulling it down. And then that base is also being operated on by our trigger switch and our global clear switch. Wait a minute. Hold on a second. I guess they're triggering ups and downs. So I got that diode in there for the global clear. That gets another 1M. All right, let's get another 1M out here. I need to find another 3904. 2. $1M5. Let's get that, and let's put that to the side. How many more 1Ms? The others are 100Ks. So that's our 1M. We'll get the 100Ks later. And then I need to find transistors. So these might be, yeah, 3906 is the NPN. If we can find a 3904, then at least we'll be using mostly the same stuff. That's the, okay, so 2 PNPs and I need 1 NPN. 3906, we're looking for the 4. Let me go to a different bin maybe? I don't know how organized these bins are. I think there were 3904s in here. Where would they be? This one? Really? Are you another 3906? Oh no, you're 7000. So on that side there's the 7000s. On this side there's the 3906s, which all of these appear to be. Yep, those are all 6s. So where are you? I gotta go to a different bin and see if there's, just happens to be a 3904, but I think, I don't know, these not the most organized thing in the world, right? Those are probably 7805s. Oh, there's a 3906. All right, there we go. I found them. I found them. Yep, 390. Wait, 6. Wait, no. No. There's just wide 3906s? I need a 4. Ah. 3904 and 3906 are NPN and PNP equivalents that are, I think, the successors to the 2N2222. That looks like a 4. Is that a 4? That's a 4. 3904. That can't possibly be a 6. I don't think it's a 6. This one is a 6. It's allowed to be. This one is not. This is a 3904. Yeah, okay, good. All right. I knew I had them. Okay, so the other pinpa. Oh my God, how am I going to wire this? Okay, we've got 2 mega ohm resistors, and I only grabbed 1. That's stupid. I only grab. You keep having to open this thing up again and grab another one. Okay, 390. No? Oh boy, where do they go? This resistor kit is a liability. I need to like figure out a better way to organize it, and I don't know. 4 or 1? One there, one there. I don't know what's going on with the clock getting mixed back into the transistor. Or sorry, to the op amp all the way over there. I don't know what that's all about. Op amp is just an inverting buffer, so maybe it's something to do with it inverting. Like our clock signal goes into 1A, skips over all that crazy nonsense. I'll have to watch the video and actually pay attention to it. Imagine. Okay, so what is this one? Just have a random resistor, 22K. That goes over there. Okay, we can do this. We can get this wired up. We got this. So data A, which is just our data input, it's got the 100K line going to ground. It has the diode that goes to the collector of a PNP. And we got to remember that the collector is the other side, because I don't know why, diodes, they have to make confusing. So it goes to the pin 3 of a 2N3906. Like this. And this is the one that's sitting off of the, hold on a second, data line. Yeah, so that's this one. And it's oh so easy to put in. Jeez. Put it up here. Oh my God. Okay, hold on. I gotta do this like this. All right. And then on that one, what the hell? I'm looking right here. So the base of that one goes to a 1 mega ohm resistor to ground. We can put the 1.5 in there. So the base goes to the 1M5 to ground. That'd be the center pin is the base. Center pin to base. There you go. And it's too tall. Cut these down a little bit. I don't like it when stuff sticks up from the board, because then you brush against it and it goes any direction it feels like. That's right over the gap, so I've just got to kind of put it to the side a little bit. Okay, and then the that pin is also switch to ground. It's button to ground for reset. So how am I going to set up a reset button on this board? Well, got plenty of tactile buttons, so we can just smash one of these little guys on here as our reset. When using buttons like this, it unfortunately, they don't really like to stay into the breadboard, so this thing will frequently fall out. It'll do for now. So I'm going to throw this like right up against here. Yeah, it just barely gets it up above where we all are. Now, is it this way or is it this way? Multimeter. Got it set on ohms. I could set it on beep and then it would just set off the beeper, but I'll just keep it on ohms, and let's just go from here to here. And that's 0.3 ohms. So we are going top to bottom on this thing. So here we've got halfway to half an ohm. What are you smoking? Here to here. What? Wait a minute, is this button just broken? Hold on a second. Wait a minute. This one to this one. Oh, yeah, okay, so I shorted it, so it goes like this. Okay, it's because of the internals of the breadboard. So overload, and then I hit the button, and it goes down to ohms. Okay, there we go. That's the way it is. I mean, I could also put it up here across the gap, but then it would fall out even easier. I guess I'll do the gap. Bridge the gap. That would be for what pin? That would be for the base, which also has a pull down on it. Yeah, so I'm going to have to jump over from there. And then it's also connected to the other PN, or the NPN that I have to install in a minute. Yeah, because it's got the arrow pointing outwards and it goes to the base of this one. So there's going to be an NPN over here. That's perfect, actually. The collector of which goes to this one. So somewhere in here, I've got some kind of a genius layout of this transistor, I think. So the other end of it goes to ground, just directly. Okay, so yump to ground. So when we push the button, we're grounding the other side of this. This goes directly to a 100K to the NPN, and then a 1M to ground, and then this thing here. So I'm just going to jump from here to here. Come on. Okay, and then the emitter, which is the one with the arrow pointing down and into the chip. It's so confusing, man. These transistors, man, because I have to call the top of one an emitter and the top of the other a collector because it's PNP and NPN. Very confusing. So this one we haven't installed yet. That gets a 100K on the base. The 1M to ground we have, but I don't have this connected to it. And then this one up and over to the trigger button, that's going to be further away. That's going to have to be the next button in the row, which will kind of be annoying, but trigger also goes to ground. So give that a little bit of space so I don't hit both buttons at once. So, okay, let me recap how I need to connect this transistor. So, hold on a sec. Let me do something here. Let me cook, as the kids would say. Wait, that doesn't help me. Hold on. One sec. I got this. Okay, new MS Paint, give you guys a view. Paste. There we go. Okay, so this right here is here. And I need, oh boy, how is this gonna, what's gonna happen here? Wait, which one is which? Hold on, one of them is coming from clock. No, that's not clock. What is that one? Well, DA is over here. Where's my, oh, it's, okay, size, red. DA. Let's see, that one's V. This one is, oh, that's the last output. QH. We got the diode and the transistor, so now we know where we are. And we can look at the schematic again and see that 4B goes to the diode, which goes to the PNP transistor, which then connects to the output of the NPN and gets a 1M to ground, which it has. So this, and this are here. So that one has to go to the emitter. There. It's going to get a little squiggly. The base goes to 100K, which goes to the button. So this to 100K to the button, which could also be over here because it's the base of the other one, right? Yeah, because it hits the base of the other one. So it's either there or here. Oh, God. Oh, God. Control Z, Control Z. And the emitter, or whatever, wait, that one goes to, oh, what? Huh? Well, hold on a minute. That was too many pins for the transistor. What's going on here? The arrow thing goes to the 1M to, okay, so there's that. That's done. And then it's the other one. It's this one over here that goes to here. And button 2 to ground. Okay, so if I can just get all this crap to do the right pins, it's a little Simon Says with the or no, Twister. That's the one. You know, the movie with the okay, so and then we'll have something that we can throw LEDs on and see them blinking lights. That'll be the more annoying part. 2N3904. 2N3904. Bop. On semi. I got a something for. No, don't do the gross jokes. See, the arrow is facing a different direction, which means the emitter is something different. It's like, why? We draw the symbol upside down. We draw the symbol so that the collector is up top because it's collecting stuff and then emitting it out of the emitter. So NPN is for switching the low side of stuff. You switch ground to things to allow electrons to flow. So collector base emitter 1, 2, 3, 1, 2, 3 on that thing. And so now we have to get that thing somehow tongue twisted into this input, the locations that I've marked on the board, which means the base and the 100K, we could put that to the slot next to that, and then we'll put a 100 kilo ohm resistor between this one and this one. So that means that we don't do this, and this instead goes here, which means the middle pin goes there. The pin with the arrow on it goes, I told you this was genius. Pin uno, yeah, pin 1 and pin 2. So what I need to do is take this thing, this little 3-pin doohickey that you guys can barely see, and I will take pin 1 is here. Pin 1 is the arrow pin. So that means we've got to do it this way, back behind. And so with that thing back behind, I need my pin flattening pliers. It's just a very flat pair of pliers so that I can actually make these pins do what I want them to. So I'll just hit it twice. This thing has been in a design before, so there's bent pins. And now I need to somehow manipulate this thing into position so that the 1 pin goes here and then the 2 pins go up there. So these need to go flat in. Okay, there we go. Beaut. She's a beaut. Well, that kind of went in weird. Well, I think it's okay. Double check. Pin 1. Yep, that's where I want it. Pin 2. That's where I want it. Pin 3. That's where I want it. We need a 100K between these two right here. And so for that, I'm just going to get a new one. 100 kilo ohms. Where's my 100? All of the ohms are in this bin. 1 key. 100 key is what I'm looking for. Is that, wait. That would be 10. Sloppily written. 100 kilo ohms are very useful in the synthesizer designs because you use them to like isolate stuff. 4.7, what did you even get in here? 470. I thought I had a whole reel of hundreds. Oh, wait, is that what these are? There's some separated resistors over here. I think I tried to get new 100s and they were, yeah, here's the hundreds. These aren't as accurate as the 1% 100Ks. So to do a hole next to the hole, you just bend this around like that. And so now you have both of the leads of the resistor, and the resistor stands up vertically, which is awesome to have near a button because that means it's going to get disturbed and then pushed all over the place and then end up not having a good connection. And then I'll go, this circuit doesn't even work in the first place, and I'll throw it out my window. All right, so that's that button hooked up. So does that mean that we can start actually like watching this thing function? Let's check with our diagram. There's still, I think, one or two things that I haven't put in. So the trigger button to the collector of the other transistor and the 100K from 1A, we're not going to put in yet. So let me see. I need a ground connection to the second button, and then I need to figure out where that junction is. That junction has nothing special about it. It's basically transistor to transistor. And they're both, it's the PNP to the NPN. And nothing else is on there? And nothing else is on there. Wait a minute. I hooked up something wrong. Let me see. Wait a minute. Something ain't right. Something ain't right. Yeah. I'm gonna get myself connected. Let's see. Writing's on the wall. Wait, that is connected. I see through you. See through you. I see through you? What? Oh, so something between... No. Hold on a second. This line right here, I think, is wrong. Oh boy. Okay, let's check over our work. So yeah, something is not correct. The NPN transistor base, that pin goes over to the other side and it goes to the pin that is directly connected to the global clear button. It does not go through no, it does. It goes through a 100K, and that also shares the 1 mega ohm resistor. It does not. Wait a minute, it does not. Hold on. I think I got completely turned around when I was doing this. So, yeah, I just got a little topsy-turvy when we were doing this. So I think I need to reevaluate what I was putting together here and maybe try again. There's just a lot of, it's a very confusing layout in this area that could benefit maybe from some pin swaps on the 4015. If you treat the 4015 as a black box instead of it being specific pinouts, you can ignore pins that you don't have coming out, and then you can swap the locations of the pins, and that'll allow you to draw the circuit in a bit more of a clear way that sort of gives better communication to the functionality of the area. In this case, things were put in to get it nice and compact. And I've failed. I've wired it up weird. At least we have all the parts in front of us and I can kind of regroup, think about what I did. So I'm going to take out the recent stuff. So this goes, 100K goes. And there should actually be two 100Ks. One is coming from the data line. This is the data input, DA. This is the other side of the diode. Okay, I'm completely turned around. Up is down, down is up. We're gonna start over. I'm gonna start over. Start over. I know that took a bunch of time and a bunch of mess, but it's sometimes you gotta just do it again. Do it again. You know, people see you do stuff like that and they, oh my God, all that work wasted. Now it's fine. I don't consider it like that. It's been quiet upstairs. I don't know what's going on today. It's actually chilly out, which is rare. Okay, so both of my buttons now go to ground. So this pin and this pin are also ground, and I can't use them for anything else. These are the inputs to the buttons. And so on the inputs to the buttons, I have all kinds of stuff. There's one path of the circuit and the other path of the circuit. Where do I start from? Let's start from the 4B output. So that would be this output right here is the last on the train of 8 positions of the flip-flop. And so, you know, we'll hook an LED up to it later on. But for right now, this is 4B. So from 4B, I am going to be branching this off and following it. And so from 4B, we almost immediately go into the anode of diode. So anode diode. So I get one of my custom diodes, fancy little guys, and I take a look at where the band is, because that will be the first thing that I get wrong. That one doesn't look very well soldered. It's in fact not soldered at all. That would be the second thing that I get wrong. That one is not soldered. That would have been an interesting issue. So let's solder that. Let's actually, you know what? I think we should solder that down. This technique is just out of happenstance. I just have all of the parts that I would need in surface mount and not through hole. So I'm building adapters so that I can use the solderless breadboard with the parts that I have. Okay, that is both connected and hurts me because it's so hot. Ow. Where is my band? You know, all this technology, and they make it very difficult to see where the little, I think it's on the right side, so I need to flip this like this. All this wonderful technology, and I can't even figure out where the freaking band on a freaking diode is. Okay, so that's the diode in. So the diode goes to one location, and that would be what I would love to call the collector, but it's actually the emitter of the PNP. And it's a high side switch, which means the emitter is pin 1. Pin 1 is to the left of the D. So that goes into pin 1 of a PNP. So that's a 3906. Pin 1, and then we'll put 2 and 3 right next to it. And we'll put 2 and 3. We'll put 2 and 3. Oh my God. This is the breadboard fighting me. There we go. The base of that transistor. Because now we're done that junction, right? We'll go junction by junction. The base is connected to one end to ground and the output of the PNP. Yes, okay, yes. Ground, and then pin 3 of the PNP, because the PNP is a different orientation and the emitter is on pin 1. So it goes to pin 1 of the PNP. And that's the base. So that has a 1 mega ohm, and I guess I got to get the multimeter out for this. Actually, it's the ones that I didn't, those are 1 meg, right? Hold on. Let's do it this way. We'll do it with the multimeter. Got to watch out when the multimeter falls over like that. It's got a mighty, mighty magnet on the other end of it, and it'll pick stuff up and rearrange things. Don't want it to. It just at that moment decided to power off. 100K. So that's a 1 hundo. $1.5M. This one is it's an OL. 1.5M. Okay, so those are the two 1.5 M's, and then here's the two 100Ks over there. Okay, cool. Cool. Okay, so we were doing the 1M from the base. The base is the middle pin of the one coming out of DA and the diode. Where are we? I've lost myself. Okay, output of the last carryover here, diode facing this direction into the, what I should call collector, but it's actually the emitter. And then this pin goes to a 1M to ground. Boss, yeah, the fish pin. Fish pin of the whole operation. I've got the schematic open in the other window, which is why I'm flipping back and forth between them. All right, so now we've done this part here. And that one's complete. Since this is NPN, well, the NPN is not in there yet. Wait a minute, we've only got the bottom piece. So now we're gonna add the NPN transistor, which we had straddling the whole thing because it goes to this pin too, which goes to this pin too. This one goes to DA. Oh my God. Okay, all right. We keep moving. So the NPN, it's like everything is interconnected in a weird way. Oh yeah, boy. So we don't have the NPN in there yet. And the way I had it before, it was straddling the two sides. I guess we'll move out from the chip. So what I need to do, we don't have the NPN in yet. DA is going to the third pin over here. And it's doing that through direct. It's actually direct. Which one is DA? Data, that's right. So that's these two pins. And these two pins get a 100K resistor to ground. So 100K to ground on these two. And that also connects, although I could put the 100K over there, but this needs to go here. And it goes there directly, but then it also has a diode. So the diode connects to the emitter of a transistor that I haven't put in yet. Okay. Jeez. I don't know why this is so difficult. Oh, that definitely, it feels like it just break in the middle. It just bent way too easily. Huh, must be real cheap. So this pin is pin 3, which is the emitter, and that goes to DA, which is data A over here. And see the button just kind of leapt out? Eesh, it's annoying. And then it gets a, okay, so this is too sloppy. I don't like this. And actually, it would make better sense if I take this pin to the other side. So we're going to bring it over here. Okay, so I brought the collector pin, or the whatever, the third pin. Oh my God. Okay, hold on. Recap. I think he used an HC595 once for a 7-segment display. I had a project when I was a kid, which was a model rocket launcher that used some of this stuff, and it had like a countdown. It would give you like a numerical countdown timer. I never got it to work, but by all means, I really should have, because this is a project a teenager could do. All right, recapping, DA has a 100K to ground, but it also goes to the transistor that is connected to 4B through the diode, and it is this third insidious pin that the arrow is not going into. The arrow goes into pin 1, pin 3, which is the one all the way on the other side of the can. So, yeah, I mean, I should realize now that I was using a fun little circuit diagram that I don't know, maybe I bought it on a Radio Shack, but it was basically a bomb. It was a bomb. All it needed was a detonator. It even had a safe to arm delay on it. I think it was a pin that you pull, but still, it was a bomb. Trigger switch, this thingy. We want the diode to the next transistor, which will be this one. And this one, oh God, collects from one, goes to the other, and then that completes all of this except for the third transistor. Man alive, this is a lot. Yeah. This is why CAD program does it the way they do. So, had a what? That doesn't sound good. Okay, so we have a diode coming off of DA, and that's facing away from it. And DA also goes to this pin right here. So I need from here to here. And I guess I can do DA right here. Yeah, that's what, because that's kind of what we had before. Okay. Would it be better if I pull it in a little bit more? Nah, it's fine where it is. Oh, this is a lot. This little, you know, it's not a ton of components. It's just like a hassle to figure out exactly the configuration of this area. In the past, I've done stuff where I've tried to like make the breadboard in CAD. By the time you do that, it's like, why not just build it in CAD and get the board, like sent out for the board to be made. That's a little less prototypey though. You can't reconfigure and customize things. All right, so that goes this way. Here. What else? There's a lot of stuff here. So we got data to ground. We got the diode coming out of it. The diode goes to another transistor, and it goes to the fuck all pin of the transistor, man. I'm starting to get really fed up with these things. Got to call them the right name, or somebody's going to call you out in chat. This would be the NPN. And then it's going into the collector of the NPN. No, arrow pointing towards the, yeah, okay, so the NPN. So it goes to the pin 3 of the NPN. This one we haven't put in yet, so I don't know where it is. Oh my God. And the 1M we have in there, so we could potentially put in the NPN, but I want to walk out from the circuit slowly. It's just, boy, oh boy. Trying to get every piece of each junction together before I move on. So we want to put this one in. And so that's the NPN. No, this one, the NPN? Yeah, because this one we already have. Or is it? No, this one we already have. This one, do we not put it? We don't have anything on the other side of the diode yet. I think I see some of what he's doing, but his schematic sucks ass because he doesn't bother to tell you where the actual power rails are being connected to in some cases. The power rails, I mean, we've got power here and we've got ground here. It seems like it's all right. I would just rearrange everything to be really clear, right? And rearrange the pins on the ICs. That's what I would kind of do. Because then you could get all these different switches and stuff to actually like show what they're doing instead of it kind of being like a mishmash and having all of these jumps in the lines. I could do with that. I could redraw this. I could redraw this much better. But I've worked with schematics for like 10, 15 years in a professional setting. So it's like I've had this stuff knocked into my dumb skull. All right, so which one are we doing first? I don't know. There's too much here. We're trying to get the emitter of that first transistor that we put down, and we're trying to get it all connected. And so this one goes to the diode, and the diode also goes to the third pin of this one. But then I don't know where the other two are going. And the base of this one goes to the switch. Oh my God. He makes it look so easy in his video. You make it look so easy. It's not. What do you mean? He also is relying on you giving the entire circuit 12 volts because the circuit he provides bucks it down to 5 for the chips using resistors. Oh. Oh yeah, they are not showing the op amps on the power to the op amps, but in the modular synthesizer, you have 5 volts and you have 12 volts, and you have negative 12 volts as well. So I would assume that the op amps are getting plus minus 12. You can, so on a schematic like this, I guess you'd probably infer it just because of the type of system that it is. But the CD4017 and 4015s, and the CDs, I think, can take plus minus 10 volts on their inputs, I think. Oh, wait, those go to positive. Oh, whoops. He's drawing his positive like I draw my negative. My negative, I do the hollow arrow pointing down. But his ground is you know, the three band ground. Yeah, I feel like I need to redraw this. Well, yeah. He's intentionally designing it with pieces left out because he wants you to buy a special breadboard system, which only provides plus minus 12 volt rails. Yeah. Well, look, I don't totally fault him for that. You know, the price of doing business is certain details will be left out because he wants you to buy his cool thing. That's fine. You know what? We can work around that. So you're saying like 0 to 12 clock here. Because we have what? The manual it provides really doesn't fill in the holes for things if you want to do it with a special breadboard. I mean, we're not doing it with a special breadboard and we're still getting by. I think we'll be fine. I mean, we're staying in the 5 volt realm right now. And if or when I convert this over to being modular, then we've got a 12 volt input, put that through an LM or what is it, 7805, you know, simple 7805. And then you've got your 5 volts and you got your 12 volts. And I think that's adequate. You take in your plus minus 12 volts, you give it to the op amps. I don't necessarily see, well, I don't really know what's going on yet with the voltages like clock 0 and 12. We're keeping it in the 5 volt realm until we can characterize what the output needs to be. And so at that point you would put it through an op amp that has full control. Oh, he's got a manual for the circuit. Take a look. I knew there was probably supplementary information, but it is fun to keep us out of that stuff so that we can interpret it in our own way. Excuse me, sorry about the cough. Oh yeah, that's a much less dirty version of the schematic. I would still completely rearrange that though. Oh, I see. And he's bringing you through all of the decisions and then possibly some of the layout stuff too. See, we made our own clock generator. We did our own. Yeah, and then it heavily relies on his breadboarding system. Because, I mean, he just made the thing and he wants to sell a bunch of it. That's fine. There's nothing wrong with that. There's, you know, it's a little... It is what it is, but there's nothing wrong with it. What are you wave shaping here? Oscillator swings all the way from plus to 12. Ah, see, we don't have a plus minus 12 volt swing. So maybe that's the devil in the details there a little bit, right? But the same stuff applies to us that's applying to Moritz's circuit is that, well, his clock, Moritz's clock goes from plus to minus 12 volts. And the way we got around that is just by using a 555 to create our own clock. Because we're working in our own sort of environment here. And so the 555 gives us timing and it gives us 5 volt timing. If I were to modularize this, then we would have to take some kind of an outside signal and manipulate it, you know, an outside clock, which isn't plus minus 12 volts. It's, you know, usually like a clock signal would be a trigger, which would be 0 to 8 volts. And so we would have to trigger off of that 8 volts and then make that into a 5 volt signal. As a teacher, there's everything wrong with that because it takes from point A to point E, but doesn't bother to tell you about B, C, and D. Well, okay, yeah, as a teacher, as an entertainer, and not somebody who's trying to sell you something, I like the gaps, but as somebody who's trying to learn something and maybe like take this into, yeah, I can see that. It's not, I don't know, I don't think it's as bad as, because like, we're talking about modular synthesizers, and so those voltages are present, and we should know about them. We know that we have to provide them and know that an op-amp needs plus minus 12 volts to the rails. The gaps are infuriating. For the uninitiated, yes. For somebody who's, I mean, like, look, the Japanese circuit book that we looked at, you were there for that, right? I think you were there for that. The Japanese circuit book, when these engineers share these things, it's like wizards writing into their tomes and sending it on a ship to their fellow wizards. Your fellow wizard opens it up and goes, paprika, I don't have that. Or like they flip to a page and they go, man, they left out Eye of Newt. I don't know why it's like that, right? Missed that one, but I get the point. Yeah, there's a, not Japanese, but there's a circuits, like a big circuits tome that I have. And we wanted to try out some of these circuits. They're from the 70s. They're what's that? This sounds right up my streets. Arcane CMOS technology. I know nothing about synthesizers. I love looking at old data sheets. Ah, you're in the right place. Yeah, so we're following a Moritz Klein circuit. And Tater's Games is a little frustrated, and I want to kind of ease Tater down a little bit here because I understand and I come from that place. I really do understand that. Because we opened up this tome of circuits from the 70s that were published in like magazines and manuals and cool stuff like that. And we're like, whoa, here's a circuit for making an oscillation. And it was this basic low-level schematic that used parts that we weren't even able to supply. And it left out so many details. I think that's just what they do. They just leave a whole bunch of stuff out. And it is something that's endemic to sharing this sort of technology and knowledge and know-how. And for some reason, they expect everybody to be read up onto the exact page that they are. In this case, I happen to be read up to that page, and I can relate to your frustration, and I can also sympathize with what Moritz has shared, because he's leaving out the connecting fibers that the uninitiated doesn't know, which is the typical op-amp in a modular synthesizer system gets connected to plus minus 12 volts. We have several different voltage levels for the signals that go on in these things. Typically, things are plus minus 12 compatible because it's a walled garden and you can plug anything into anything. You whoopsie poopsie, I plugged your speaker into 12 volts. Oh no, yeah, I plugged this input into this sound source. it doesn't matter in modular synthesizers. Everything needs to cater to those voltages. And so the way you do that is you have operational amplifiers working as buffers in the system. Buffers, not like, you know, little dogs. You have them working as buffers. And so that's sort of an implied when I'm reading about what he's put down in the schematics here. He's not showing you that this might be a quad op amp, in which case certain pins will be plus and minus full power. And the CMOS chips in this case that he's using might not be compatible with plus minus 12 volts, although I think these are 10 volt, plus minus 10 volt compatible. But the ones that I'm using, and this is further confusion on the whole thing, and this is kind of why I'm doing this, is that these are 0 to 5 volt compatible. They will not even interact with the plus minus 12 volts, and that they'll heat up and explode. So in addition to being a teacher, I'm also studying towards an engineering tech degree, and it would be wonderful to see all of the pieces, but positively infuriating when you're walked through how to make something, but you haven't learned anything except how to follow someone's directions. Yeah, that's so. I mean, Moritz goes through the higher level decisions on how the waves are being made and stuff like that. It may not be low level enough for the uninitiated, and I don't know where you would get that kind of content. I'm not sure. Maybe like tutorials and stuff like that, or op amps how-tos on the internet. At a certain point with the stuff that I know, like you need these many volts here, this many volts here, I can look at the stuff that Moritz is doing and kind of say, oh, okay, we're putting a filter there, we're doing this, we're triggering off of that. If you guys haven't noticed, the reason that I'm totally deflecting right now, and it's a good discussion, and it's just about all this stream has, because I really need to like take a step back and redraw the schematics so that I can understand what the hell's going on. I am getting completely and utterly bogged down in the ins and outs of the transistor diagram. But like these transistors don't even have part numbers on them. And so, yeah, in the past, I would go through this and I would be like, I don't know what value to put on this transistor, and just find anything and put it in there, and then it would end up not working. This does walk you through stuff, it looks like, though. But it looks like you need his hardware in order to go as smoothly as this tutorial is. I'm not following this tutorial. I don't want to follow this tutorial. I want to just like throw stuff in. Page 62, 20. Oh my God, there's a lot here. I wasn't going to look at this at all. This does kind of step you through the design process, though. It's pretty neat. It might not be for the completely uninitiated, but if you want to learn, oh, look at this. What is this? This is how to build their kit. You can buy it as a kit, by the way. But if you want to like, yeah, it seems you need to buck up on some of the basics to, okay, so this is literally like the whole drum machine. Yeah, so we're building one of the voices. This might actually be a little bit more clear for me. This is probably what they use to build the circuit boards. So yeah, the full schematic will have it. Oh, it is Erica. Ah, ah. The kit is like not cheap though. Let's see how much that is. This little guy, 110 euro. I guess that's for the thing. What about the kit though? EDU DIY drum sequencer. Oh, so this is just the ideas thing. Showing it off. Whoops, there's already a mistake. Ability to free play means no clock, just jamming and tapping. I guess they came up with a way to do that. Yeah, so there's a full schematic. We weren't going off the full schematic. I just want to... That is the kit? Okay, so the kit's 110 euro. Ugh. I would rather just build that for myself, which is kind of what we're getting to. Because I think this was originally a Hackaday thing. Walkthrough does describe what it does and why, but it won't teach basic electronics. It's worth watching the video as it describes every part of the circuit. Yeah, I'm going off of the video. I imagine most of the cost of that is the metal plate. It's the one thing that my synthesizer's missing, and I really need to come up with a way to label things on my synthesizer. But it's PETG, and none of the label stuff sticks. And I guess maybe one thing that I could do is go down a size of nozzle. If I go with the smaller nozzle, I might be able to get the tiny text in there with decent enough detail. But that means recalibrating everything and making sure it works. Listen, I am getting absolutely killed by having to do this weird transistor layout live on the air. So what I'm gonna do is maybe on Wednesday, I'm gonna sit down with a pot of coffee and put that all up. BC548 NPN and BC556 PNPs are the transistor in that circuit. Oh yeah, because we actually saw the big schematic. I don't think the 3904 and 3906 are going to necessarily... Wait a minute. Oh, there's a lot of like basic explanation all the way at the end of this. We're describing PNP and NPNs. And different types of op-amp buffers and op-amps in general. Maybe you got to check out the appendix stuff down here. Coffee helps me too, yes. Clear thy mind. Yeah, there's a lot of good stuff down here. I don't know if it specifically goes over the sort of mid-level stuff that I was talking about a minute ago, but that might be very useful to go down and check out the index a little bit. It's almost like he gives a huge amount of info. Yeah, it can be confusing for the uninitiated. I totally understand where Tater's coming from, for sure. So, I don't know how crucial the BC558 and the BC548 are. This is drawn so much... Oh, this is so much nicer. Except for the... I do appreciate having a ground symbol on these things, but this is... Yeah, I may have to use this schematic to put it together. This makes so much more sense to me. Yeah, so the fact that it's tied back to buying his breadboard does make it feel like a bit of a rug pull, but it is good information. You don't find a lot of creators making like a easy to watch video that builds you through the design process, and that's sort of what I saw in it. Somebody who's already familiar with the modular synthesizer circuits. So yeah, maybe some of the appendix information will help sort of bridge the gaps. I hope so, because I don't like showing people something I like and then it puts them into a fit of frenzy about how badly it's put together. Like, wait, no, I read it. I understand what's going on. I thought it was okay. All right, I'm packing up, you guys. Unfortunately, the blinking lights that we got were the ones that were at the very beginning. I wanted to hook up the big bank of lights to this thing so that we could see it carrying over the registers, because that's the cool part, is with the little piece of clockwork in front of me humming along. This is all I was able to do, and I didn't even do it today. I was just able to get this thing to binary count. And it is binary counting, but the LED broke. What a pathetic stream, Bother. What are you doing? Look at that. Why isn't that lighting up? I think my resistor's broken. I just have to find a new resistor. That's how it goes sometimes, though, you guys. It's not the LED. If I pinch the resistor, it actually lights up again, so... This is pathetic. I can't even get a green LED to light up. It was just a piss stream. Ugh. Okay, so this is what we've got so far, and it doesn't work yet. We've got a 555 timer against all of my kicking and screaming about how much I freaking hate 555 timers. I happen to have one in this circuit. Very annoying. Anyway, I had to do 2 different configurations in order to get a 50... what was I going to say? duty cycle, 50% duty cycle. Duty cycle is what percent of the time you're either lit up or not, right? So 50% duty cycle, it's on and off at the same amount of time, depending on where I adjust the resistor that's charging the capacitor. Great, 555 timers. I did something with one. You guys can all praise me later. Anyway, we've got that going into a 7.4 LS93. The 7.4 LS93 is an up dog. What did you just ask me? An up dog counts every pulse that's going into it. It's an up timer, an up counter. And what that does is it takes the, I guess, serial timing signal and turns it into a binary coded number. And if the green LED would work, you would see that this is going 1, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, et cetera, et cetera. It's counting in binary. It's a little confusing because they go back and forth like that. So that's counting into a parallel register. And we use that as a breakup for the timing. So we can go half time from the second digit of this thing. We could go very slow indeed if we wanted to, or we could go extremely fast, the same speed as the clock. I don't know, on Moritz's thing, it's a little confusing. And on the circuits that I looked up for the 7.4 LS93, you see, Moritz is using completely different hardware. Our tutorial, it's shit. It uses completely different hardware because I have 1001 7400 series logic chips. I do not have any of the CD something or other. So our pulses are coming in. These are half timed over here. They go over to the next stage where there's a bunch of bullshit going on. What this is it's a serial to parallel shift register. The serial to parallel shift register is going to do kind of the same task, but we're going to be able to actually like charge ones and zeros into it as the timer ticks us over into the next shift register. We can do that for 4 voices. That means I have to put together a lot of circuitry, but we can do it. Probably won't save me if I just buy the kit from Erica Synths. It'd probably be much easier to do. But we want that shifting action to happen. We were getting there, but things were just a little bit topsy-turvy for the circuit, and I wasn't really able to get it together. We got parts together, and we talked a lot about the tutorial itself and stuff like that. You guys should check it out. It's going to be in the YouTube thing, in the Doobable, whatever. And then there's also, if you really want to like type this in manually, or I guess Twitch chat will remain with Twitch until this thing goes into things. But Tater Games found the entire tutorial, which is pretty cool. I like the CMOS for the low voltage, so that's mostly what I have. It's hard to find the parts for some older circuits. Yeah, we had to find 7400 series equivalents, and we actually found a chip that's an entire 8-bit shift register. So the 2 4-bit shift registers were tied together in order to make an 8-bit shift register. We already have an 8-bit shift register, so there's some little alterations here and there that we do with the circuit, but as long as our basic understanding is there, we can get through the whole thing. Oh my God, I'm hiccuping. I tried last night. I had Wagyu beef. It was great, but it was not something that I'd want to eat all the time. Anyway, I had some of the leftovers from that dinner for lunch, and it turns out all the fat is starting to make me burp because I'm talking a lot. So let me just update and put Tuesday's date into this command here. And then I will do, not Tuesday, sorry. I hope everybody voted. The 6th, which is Thursday. I'm back on Thursday, so I'm going to have Wednesday to like contemplate my life and figure out what I want to do with this circuit. Because I'd very much like to actually build this. Yeah, these were like little tiny pieces and they were done perfectly. So I can say that I've experienced Wagyu beef, and that all of those YouTubers who buy like an absolute slab of it are completely and utterly bullshit. They're completely wasting your and my time. A big slab of Wagyu beef cooked to perfection is too much, like this much, and then go eat a bagel. Like, because you're definitely going to need something to absorb all that fat. It's amazing. It was very, very good. But again, I'm happy having experienced it once. I will take a normal steak any day of the week over that. Yeah. Your workshop looks unreal. It's everything that I own in one room of a house. I did a lot of consulting out of it for a little bit. That recently that's kind of dried up and I need to get back to that. But yeah, we work on projects and I've basically, this is me. Like this is what I am. I don't own much else outside of here. My bedroom is just like a bed. I would like to justify the ownership of this entire shop, and to do that, one day I'll have a car project, but until then we are working on this guy over here. We've taken a little bit of a turn from the normal burn the subs. We'll get back to burn the subs. There's a lot of like programming and configuring and systems engineering stuff that we need to do with burn the subs to get it back up. That's going to be a, I guess, Node-RED powered laser etching table that's connected to my wall. And when you subscribe on Twitch, it'll burn your name in a random location. We've got a lot of work to do for that. I've had 2 other versions of this board that worked. So we've got a base to kind of build on. We're pretty much like 90% done with hardware. I need to do wiring. And then we do systems checks one by one in order to get the whole thing running. But that's a lot of software configuration too. So I was understanding what you were doing just fine. Oh, no, it's okay, Tater. Yeah, I understand. I understand where you're coming from. My explanations took a long time, and we didn't get a lot done today. I'm very annoying about that. Very annoyed about that. Sorry, I'm trying to read and talk at the same time. It's like, why is my other hand circling? Why is it circling? You're supposed to pat one spot. Zero technology outside my nerd room, small worse version of your shop. Yeah, this is a problem. This whole shop, this is a problem. Somebody's gonna have to deal with it one day. But yeah, so we try to do a variety of projects on the channel. We've been working on burn the subs. We've been doing some WLED stuff. I got a dog collar that I would like to light up with pretty lights. We got to work on all these things simultaneously. And then every now and then a project kind of falls by the wayside and chatters come in and start harassing me about it. And I get pissed off. So we'll get back to that this week. I have a regular stream schedule. I don't think anything crazy is happening. I will be back in approximately 1 day, 20 hours, 16 minutes, and exactly 36 seconds. So I will see you guys then. I'm waiting for the day when you can perfectly sequence the farts into a tune. So, Father, why is it that your Discord channel is 1984 mixed with communist China regime? Why am I not allowed to post my joke song in your music section? Well, because I go through the music section and I listen to it. I might not listen to it right away. I listen to all this stuff. Oh yeah, and if you're wondering, name the dog or name the kink. It's her name is Willow and she's a corgi. She's on all the thumbnails for the dog streams, but it's a WLED light up dog collar that makes all kinds of pretty patterns. I could use it for anything else. I don't think I can sell it because it's just using WLED, but it's one of these Pedalsy dog collars, and then I got 2 rows of 2.5 millimeter wide LED strip, and it won't last for very long, so it's not really good for the fetishy stuff. If you're going to like a convention floor, you want several hours out of the thing, and this will not last that long. This is good for the daylight savings time walks that I take the dog on. She's a fluffy corgi. She's the cutest corgi on the entire planet. That you may not know about, it's the fart box. This thing also works off of the Twitch API on Node-RED. If you watch the show on Twitch, you earn channel points, which is the worst acronym ever. But you get channel points, and with those channel points, you can spend them to, well, only set off a fart. There's 9 farts in this thing. It's a dollar store fart noise maker that we hooked up to an ESP8266. We took it over, we hooked it up to Node-RED so that the MQTT broker will say, hey, set off a fart, and it will. Hope Will's okay. Oh, she's great. She's doing great. She needs to be seen in the dark. Yes. The reason I bought another dog collar was because this one is actually the one that I walk her with. It has a solid white LED, well, there's 4 or 5 solid white LEDs on the strip. It doesn't light up as much as I'd like it to, but it's enough that she can be seen. So I've got, Willow is fully illuminated out there. But I want I want her to sparkle. I want cool sparkles, and then when she barks at something, I want it to do like a flourish. WLED is perfect for that. We might do WLED on Thursday, depending on whether or not I like what I'm doing with this drum sequencer. The drum sequencer, it's going to be kind of a big project, but I want it. Like I want the drum sequencer. I don't know. I might just cave and spend 110 euro and get that shipped in, and we'll just build the kit. You know, we kind of understand how it works. I would really like to get the breadboarding stuff done a little bit more though, because you guys can see new people are coming in for this kind of stuff. Like when we change projects, we get 1 or 2 new people, and that's kind of the lifeblood of the stream. So anyway, I'll be back on Thursday. We'll see what we work on. I know what I need to do in order to get the willow collar working, I think. And so we can try to implement something and see if it breaks. So, all right, I'll catch you guys Thursday. You saw the end card. You already saw that. You've seen everything. There's nothing more for me to reveal to you. Everything is known.